Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hello, this is Jace Fugate. I'm going to be going over the introduction to the Go programming language. So in this session, we're going to be going over how to install Go, just the basic setup, and we're going to talk about the Go path and also known as the Go workspace. We'll also give you a way to test your installation of Go to make sure that it's working correctly. When it comes to prerequisites for this course, there are none. You just have to have a computer, which I'm guessing you have because you're watching the video. And you need to have a text editor, just some way to edit text files. I use VS Code. You can use Atom, you can use Sublime, there's brackets, there's a whole lot out there. Just do a quick Google search for text editors, pick one and just try it for a little bit. If you don't like it, try a different one. If you like it, just keep with it. So let's go ahead and dive in. A little overview of Go. It's an open source, statically typed, compiled programming language. I personally like statically typed compiled languages. That's just a personal preference for me. What's nice about Go is you have the niceties of a statically typed language, but some of the syntactic sugar of a dynamically typed language. Go has something called type inference. We'll go over that a little bit more in some of the other sessions. But it's mainly used as a back-end server-side language. It builds very quickly, and when it runs, it's very fast and efficient. It's also just a very reliable language. Some of the highlights are, again, it has type safety because it's statically typed. It's also memory safe. So you're not going to have the manual memory allocations like you would in C or C++. The concurrency support in Go is great. Concurrency means multi-threading. That means you can do, concurrency doesn't always mean multi-threading, but it basically means you can do two things at once. And it's very easy to communicate those things that are trying to do two things at once. There's latency-free garbage collection. Again, as I said in the last slide, the speed of compilation is very fast. So you can write something in the language, compile it, and test it very quickly. And the built-in tool belt that comes with Go is really comprehensive. It's really great. So Go has distributions or installations for all the three major operating systems. It's really easy to install Go. I'm going to go ahead and switch over here to the Go homepage. So this is the Go homepage. You can just click download Go. And you can see there at the top, 3 operating systems. Scroll down a little bit more, you have all of these different installations. So for different operating systems, for different architectures, and then different types of versions. So you can have directly from the source, you can have an archived version, or there's also like installers for Mac and for Linux and for Windows. When it comes to Mac, you can use something like Homebrew to install Go. With Linux, you can use something like apt. I will say apt most likely will not give you the most updated version. And then when it comes to Windows, I would just use the installer that you can get on the go.org homepage. But follow your course materials. It will give you a step-by-step guide to install Go on your machine. So as I said before, the Go tool belt that comes with the standard just Go distribution is great. It's what you're going to use to build, test, run, and also download third-party dependencies. We're going to be going and using this tool and the other sessions a lot. You'll get to know it quite well. So a little bit about the Go path or the Go workspace or just the convention of how you organize Go code. So normally you put it into one workspace, or you put all your files into the Go path. The Go path is a file or a directory on your file tree on your computer. The default location is your home directory /Go. You can change this to wherever you want, but I would just keep it just at home /Go. I've never had a reason to switch it around. But the Go path or the Go workspace has 3 subdirectories. We'll go ahead and talk about those. You have the source subdirectory. And that's where you're going to put all of your code that's going to be compiled down into a standalone binary. So you have a whole bunch of directories inside of there. Each directory is its own package, and you will compile that package down, and then you can then distribute it as a binary. The bin directory is where you put binary executables. What's nice about this is the bin directory should be in your path. If you don't know what that means, it basically just means it's readily available on your terminal. So you can have an executable or binary in that directory. You can then run that binary just in your terminal by calling the name of it. And then you have the package subdirectory. It's where you put archives, non-executable packages, aka shared libraries. You put them all here. So if you're going to be having something that's you want to be able to use it, but it's not going to be compiled by itself down to a standalone binary, you're going to stick it here. When it comes to testing your Go installation, really the best way is you write a simple program, a hello world program, just prints something out. And if that runs and compiles and you can run it, then you probably have everything set up right. There is an easier way also. You can switch over here. So here's my terminal. I'm going to go ahead and clear so you can read it. So you can actually type in Go space version, hit enter, and that should print out the version of Go that you have installed. If it says something like, I don't know what Go is, or I don't know what you're talking about, then that probably means you don't have it installed correctly. You need to go back and try again. You can also type in Go space env or Go environment, and it's going to print out all the environment variables that you have that are Go centered. So you could go ahead and create this little program and compile it and run it, and if that ran, it would work. That means that, hey, you have your Go installation correct. We are going to be going over this in the next session. And so let's just talk a little bit about what we've done today. So we gave you a little overview of Go, talked a little bit about the tool belt and the Go path. We also helped you install. And then we gave you a way to be able to test your installation. In the next session, as I was mentioning before, we're going to switch over from this PowerPoint to hands-on. We're actually going to be going into the code. We're going to be writing, and we're going to actually have you write your first simple Go program. We're going to write the Hello World program in Go. And the course material that you have should cover in more detail all the topics that are discussed in the remaining sessions. So as I said before, we're going to be going over Hello Golang, or the Hello World program in Go. So hopefully we'll see you there. There's a couple more resources here. So if you need some extra help, we do have weekly and monthly plans. There's a couple other follow-up courses you can look into if you desire. Thank you guys so much for being here. Hopefully we'll see you soon. Hello, this is Jace Fugate with the Introduction to the Go programming language. So today we're going to go ahead and dive into the code, and we're going to write our first Go program. And so you're going to want to open up your text editor, or I guess you could just go on to use your Windows Explorer, and go into your Go path, open up your source subdirectory. You notice I have a lot of stuff here. You probably won't. It's just that I'm actively using the Go programming language pretty often. You're going to want to create a new directory inside here. We're going to call that Hello, as we're going to be making a Hello World program. And inside of this new directory called Hello, create a new file, and then call this main.go. So you really doesn't matter what you call this file as long as it ends with .go. But just by convention, this is going to be the entry point to our Go program, and so we call it main.go. It's going to be the main package, and it's going to have a main function. It's just a great convention to follow to be able to keep things organized. So as I said before, we're going to go ahead and call this the main package. So package space main. And we do have to call this the main package. Go, when you compile this down, it's going to be looking for a main package. And then we're going to make a function. So we're going to type func space main. We're going to be making a main function, again, the entry point. We're going to have some parentheses. This is where in the future, if you're writing a different function, you put parameters. You want to do an open and a closing curly brace, and then return. So now technically we have a running program. We could actually just go into the terminal, type go run period, or this directory, run this directory. And if I hit enter, oh, actually before I run, I need to make sure that I go into our hello directory. So I'm going to cd into source hello. Now I'm going to write or type go run period. If you're going to be on a Linux or Mac, it'll be like this. If you're going to be using a Windows, the paths are a little bit different. Instead of a backslash, it'll be, or instead of the slash is going this way, it'll be the other way. It'll be a backslash instead. But we'll go ahead and run it, and as you notice, nothing happened. Well, nothing happened because, well, we don't have anything happening in our function up here. So let's make it do something. Let's go ahead and type in here fmt, or format. We're going to be using functions from the format package. I'm going to type in here print, and you notice how my editor will show me I have printf, println. Let's go ahead and use the print function. So you do fmt.print, and then you put 2 parentheses at the end. This is where we're going to put what we want it to say. If I save, you notice that my code editor will go ahead and import the fumpt package. Your text editor may not do that, and if it doesn't, that's okay. I'll erase this in. We just want to type that in. It's type import, and then double quotes, fmt, or whatever package it is that you want to import. If you're going to be importing more than one package, you would type it this way, and then you could put another package up there. We are just going to be importing one package, so let's just keep it the standard, or the simple way here. So now we've imported the fumpt package. Down here we're using the print function from the fumpt package. Now we want it to say something. So if you want to put in a string for it to say, or a word for it to say, you need to put double quotes. Don't use single quotes. In Go, double quotes and single quotes are not the same. But you can type in those double quotes and you can say hello world, or whatever you want it to say. It doesn't matter. So I'll go ahead and save that. And now if I type go run, period, you'll notice, hey, it prints out hello world. But you notice how it put my hello world on the same line, or like my terminal kind of just got pushed over. So there's the other function that was there that was println. This will actually put a new line character at the end of whatever you type. So let's go ahead and run that again and see how it jumps my my prompt down a line. If you wanted to, you could just manually type in a \n here. Doesn't matter. It's whatever it is that you like. So there we have it. We have our hello world program. Now let's go ahead and build it. Let's compile it down to a binary. So we can type in almost the same command. It's go build dot. I'll go ahead and run that. If you notice in my file tree on the side here, well, we have a new file that just popped up. That's our hello binary. It'll be named after the directory that it's in. Now let's go ahead and run that. Let's type /hello. Notice it does the same thing. One thing to note though, if I were to change this file and I were to expect, oh, hello world still only has the 1 exclamation point. Well, it's because I was just running what was here. I wasn't running the build executable. So let's rebuild that so that we can see the change. Go build dot. Now if I type hello, it'll have the 4 exclamation points. So if that's worked for you, congratulations, you just wrote your first Go program, and you know for a fact that your Go installation is working properly. Thank you so much for being here. Hopefully we'll see you soon. Hello, it's Jace Fugate here with another session of the Introduction to the Go Programming Language course. So I went ahead and typed this out for you guys. I'm going to save some time. I know everyone's short on time. As these files get bigger, I'm going to probably just type these out beforehand instead of just typing it right in front of you. Again, just to keep these videos short and quick. If you look at your course material, you should have more in depth on each of these topics. So I created a new package called var, and in here we're going to talk a little bit about variable declaration. So there's different types to declare variables. So far what we've always seen is the var, name of the variable, the type equals, then the variable. You've also seen the type inferred version where we just omit the types, and Go just says, oh, well, my string, and you're making it equal to a string. So it just knows, I'll make this a string. This is of a type string. You can do multiple declarations in one var statement. This usually, how I use it, is I'll put it up here at like the top, outside of any function declarations. But you can say var, and then I have employee ID is an integer that equals 5. And then I have 2 variables that are strings. You can put them all in here. And
thanks for watching. Feel free to add your questions as comments down below.
just like how with the import, you do import and then you do the parentheses around it if you want to have multiple parentheses or multiple imports. You do the same thing with variables. And then there's something new for you guys. This is the short variable declaration syntax. This is really nice. It's the colon equals. You'll see this a lot. So instead of having to type out var at the beginning, equals, you can just put a colon. And this will automatically just do a type inference that this is a string, and now it's saved into the name variable. And you can use this when you say declaring multiple variables as well. You have age, salary, and is a programmer. But you notice here these are of different types. So we have 35, we got an integer here, we have a float, and we have a Boolean. You can do those all at the same time. Something to note, in fact, let's just run this. Go ahead and run this. There we go. Hello, we have all the variables that we were declaring. So we can take this guy, all of these guys, if we really wanted to. We could take these out of the main. We'll talk about scoping in another, variable scoping in another session. You can take them out, it's fine with it. You can take this out. It's going to be perfectly fine and dandy with you just taking this out, popping it in outside of the function. If you try to take this out though, it's going to be a little upset with you. And what does it say here? Non-declaration statement outside of function body. So you can't do the short syntax outside of a function. It's just the Go programming language developers, designers just decided that that was not something that they would allow. So if you're using the var syntaxes, either of them, you can declare them anywhere. But if you're going to be using the short syntax, it has to be inside of a function. When you're new to this language, that can sometimes be a gotcha. Some people wonder, well, why do you ever use a short syntax? It's just a personal preference. You'll learn what you like, you'll learn what you don't like, and as you work with other developers especially, you'll come together and figure out some kind of consensus on what you guys like. It's just code design, I guess you could say. So again, we'll run this, prints out all of our variables. So thank you guys so much for being here. Hopefully you enjoyed and you have been enjoying learning the Go programming language. We'll see you again. Hello, this is Jace Fugate again with another session of the Introduction to the Go programming language. So I'm going to start this from scratch today. But we are going to be going over zero values. So let's go ahead and create a new package. Just call this 0. Create our new file, main.go. Main package, create our function. So I'm going to create a bunch of variables all in one block. And we're going to be talking about zero value. So in a language like C++, when you initiate or instantiate a variable, if you don't give it like an initial value, it's kind of unknown what that value is before you initialize it. You have a variable, it has a type, but you don't really know what's in there. And in fact, it's just whatever random ones and zeros happen to be in that memory slot on your computer before it ran. I guess it probably depends on the compiler. But we'll go ahead and do a string. Let's say my string, say string. We'll make an integer, call int, we'll make a float, do a float 32, 64. I guess it doesn't really matter too much for this. We'll do a bool. And let's go ahead and print these out so we can see what those zero values are. So for our string, use the string verb. For our integer, use the number verb. Float, f, and for the Boolean, you use t. If these verbs are confusing to you, you can always use a V, or you could just put them in here directly. I would learn the verbs. They're very useful, especially if you're going to be doing a lot of logging. You can look into your course material and learn more about these verbs, or look online, look on Google. So let's print these out here so that it stops being mad at me for not using the variables. It doesn't want me to be wasteful. It's a good linter. So let's go ahead and cd into our new directory that we created. Print this out. So string, it's nothing. It's an empty string. Integers is 0. Floats is 0. Booleans are false. And that's always going to be the case. When you instantiate a variable, it always comes with a 0 value. And for strings, be the same as if I did that. For an integer, same as if I did that. For float, same if I did that. A Boolean is always going to be false. These are nice so that you don't always have to instantiate your variable with a value. All types have a 0 value. As you go through Go and as you use it more, you'll be able to have these just as second nature. You'll always know that, oh, I made a string and it's going to be an empty string. If I'm using a pointer, we'll talk about pointers later, then it's going to be nil. If I use a struct, then whatever that struct or that object's fields are, whatever the field's 0 value are is what the struct 0 value is going to be. We'll talk about that more in the future. But go ahead and play around with it. Try all the different types. Try different types of numbers. Try runes. Try some bytes. Booleans are great. I guess there's only really one Boolean, just the true or false. Yeah, but try things around. See what you can learn. Thank you guys so much for being here, and we'll see you again. Hello, this is Jace Fugate with the Introduction to the Go Programming Language courses. So let's go ahead and jump into the numeric types in Go. So go get into your Go path here, open up the source subdirectory, and let's create a new subdirectory inside the source subdirectory. Create a new directory in there. We're going to call it numbers. And just like the Hello World program that we have right here, we're going to create a new file. Let's call it main.go. So let's go ahead and give this the package name main. Again, this is the entry point to our program, so we want to have a main package. Let's write our main function. So you got func space main, the parentheses, and the open and closing brackets. And so in Go, when you create a variable, or if you don't know what a variable is, it's kind of like a bucket where you can store things. And in Go, because it's statically typed, once you say this bucket can hold this type of thing, you can't change that. So we're going to type the word var for variable. And then you want to give it a name. Let's say my, I don't know, 8-bit number, my 8-bit. So we're going to make an int 8. So that's an 8-bit signed integer. As it says here, it goes from -128 all the way up to 127. So we can say now equals 10. So there you have it. Now if anywhere in my program where I use my 8-bit, that means 10. You can't go in here and say, you know what, I want my 8-bit to equal hello. It won't like that. The program won't compile because it has to be a number. So you can change it. It's variable. It can change, but it has to be an 8-bit, something that looks like an 8-bit integer. But there's other types here. So let's make an integer. So let's say var int, and we could type like that. And if we could type int, or if we wanted to, we could use something called type inference, and we can actually just omit that int, and Go will automatically say, hey, if it looks like an integer, I'll just make it an integer. That's the default type for a number. So we'll leave it like that. Now we also can use an unsigned integer. So let's make another variable, and we'll call this my uint. In fact, let's keep with this naming notation here. Int 8. So uint, and it gives us a whole lot of different options here. We have a 16-bit, 32-bit, 64-bit, and 8-bit. The larger that number is, the bigger the number it can store. Let's just do a regular uint. And let's make this 15. So we couldn't do -15 because it's an unsigned integer. You can only hold positive numbers here. Make another variable and call it my hex. So my hexadecimal. So we're going to put a 0x or 0x. I see how it turns red there, just letting me know that, hey, you're typing in something special. So this is a hexadecimal number. And that 0x is a prefix that tells Go when it compiles, hey, this is a hexadecimal number. So let's go ahead and jump on to another one. So let's say bar my octal. So this is going to be octal notated number. There we go. We also have some things called floats. That's what you think of as like a decimal. So we have a float 32, a float 64. Either way, again, the bigger the number, just the bigger you can, the larger the number can be. So let's just do a float 32 equal 9.3. And we can use type inference again here. We can actually say, just omit the type, as I did here. So we can actually just omit the type down here. And Go will just say, hey, I know it looks like a float, so let's just call it a float. So now if I type in here my float, it recognizes that as a symbol. So we can go ahead and run this, or try to run it. You'll see what happens. It's going to yell at me. Oh, let me make sure I jump into the correct directory here. Go run. Oh, give me a bunch of errors. It says that all these things are declared, but they're not used. In Go, if you don't use a variable, it's mad at you. It doesn't want you to be wasteful. It doesn't want you to say, hey, here's a bucket and store some data in here, but then you never actually use it because that's just a waste of memory. So let's use our handy dandy fumped package. We're going to use a different function this time. It's going to be printf. I'm going to go ahead and save. Again, if your text editor doesn't automatically import that, just go ahead and put that in. And let's print out all these numbers. So we can actually use a special notation in Go for all of these numbers. So the D is for numbers, for just like your integers. And then we can use a #x for hexadecimal. You can do, again, these all are prefixed with parenthesis, didn't say that. But the special format strings are prefixed with a parenthesis. O for octal, and then F's for floats. Let's put a new line here. Let's see here, my int, my int, my uint. Type all these in. Oh, look at that. There we go. So now if I run this program, it'll print everything out for me. So here we go, 10, 115, you got that hex number, this octal number. Sec. Then 9.3, 5.6. There you have it. These are the basic numeric types in Go, and you can do all sorts of math with them, and we'll go over that more in some of the other discussions. Thank you so much for being
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
here. Hello, this is Jace Fugate with the Introduction to the Go Programming Language courses. Let's go into our Go path here, open up source. Today we're going to be talking about characters. Specifically, we're going to be just looking at, a quick look at bytes and runes. So inside your source subdirectory in your Go path, let's make a new package. Let's call this char. We're going to be going over characters, so that seems fitting. Let's create a new file. Call this main.go. And in this file, we're going to be making the main package. And then create your main function. So func space main parentheses brackets. So let's create a variable, var space, let's call this my byte. It's going to be of type byte. Let's put a single quote. This is important. Make sure it's single quotes, not double quotes. We're doing a byte here. We're not doing a string. Let's do letter A. So that's going to hold the bytes of the letter A. And if you do var, let's say my rune. Let's type in rune as the type. Single quotes. I'm going to paste in a heart. This is like a special character. Okay, let's go ahead and print these out and see what we get. So fmt, we need to import the fmt package. We print.f. So it'll print what we're going to use the special formatting string. So we're going to format a character, C. And let's print out the number here. Type in another character equals U. Well, let's format these. So we're going to be typing in my byte twice. We're going to format the same variable in two different ways. Same thing with my rune. Okay, let's go ahead and cd into our new package. Let's run this. So go space run space period. See what it prints out. A equals 97. So the byte value of A is 97. And in fact, let's switch this to B. Give us the that'll give us the binary version if we wanted to look at that as well. So that's the binary version here. And then heart equals U plus 2665. So those are characters, bytes and runes. They are different than strings. You gotta make sure that you remember that bytes and runes use single quotes, and a string will use a double quote. Again, go ahead and check your course material. You can find out more about these types. Thank you so much for being here. We'll see you again. Hello, this is Jace Fugate with the Introduction to the Go Program Language courses. So today we're going to go over a little bit about the math operations that you can do in Go. So let's jump into our Go path, open up the source directory. Let's create a new folder and let's call it, I don't know, math stuff. It's a great name. So let's open that up and make a new folder called main.go as we have in the past. Again, this is our entry point to our program. So package main, let's create our main function, func space main parentheses brackets. So let's create two variables, something that's really nice with Go. You'll see this in a lot of other programming languages. The one that comes top to my mind is Python. But you can declare two variables at one time. So we just declared two variables, A and B. A is 4, B is 5. This, you see here, it's a little mad at me because I'm not currently using it and I saved it. So it thinks that I should be done, ready to build. I'm not. Let's create another variable. We're going to do just a little bit of arithmetic here. So you can use parentheses, so A plus B. You can use a quotient or a multiplication. do another parenthesis here, a plus b, and then you can divide. I'll format it for me again. It's saying that, hey, I'm not using the res1 variable. You could make this a negative sign if you wanted. One thing that's also cool in Go, you can use the plus plus operator. So that will just take whatever number you have. Currently a equals 4. You do plus plus on it, it'll increment it. You can also use minus minus, that will decrement. So we can keep that there. You also have like a plus equals, so let's take b. Let's take it and add whatever it is plus 1. So b plus equals 1. This is the same as doing this right here. It's just a shorthand so that you don't have to type b twice. Again, you can use the minus sign version if you wanted. Let's make a new variable here. It's called res2. We can do bitwise operations. So this is an XOR. You normally think of that as doing a exponent. It is not exponents in Go. So that will XOR A to B, A and B. Let's create R. So we'll make a float here. And there is a library that is very useful. It has a lot of math things. It's called math. Math.py. Of course, 3.141, whatever it is. I actually don't know past the second decimal. There we go. Again, it's mad at me because I'm not using these variables yet. So let's go ahead and let's print these out and see what we get. And let's use also a new verb, format verb as it's called. Let's use %v. This will just format to the best of its ability. It'll take whatever you give it, doesn't matter the type, and it will just try to format in a way that it thinks it will be useful for you to use or to read. So let's type in res1, res2, res3. There you go, now it's happening. And also it did the automatic import. As you notice up here, we're importing two packages, the fumped package and the math package. And it does a different syntax than what we have seen before. It uses a parenthesis and then it puts in each package with a new line at the end. Let's cd into our new directory and let's run this and see what we get. There we go. In fact, let me stick a new line on the end of this. It'll make it a little more legible because it won't slam my prompt there at the end. So here we go. Response 1 or res1 is 40, res2 is 11, and then res3 is 38.84, or I'm dyslexic apparently, 4845,100, blah, 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 blah. So there you have it. You can do math with integers. You can do the increment and the decrement. You can do a combined increment or decrement if you make this a negative. You can also do bitwise operations. You can do math with floats as well. One thing to know, if you try to do math between like a float and an int, they're different types. You have to keep in mind that you want to be doing math with similar types. So again, check your course material and play around with this, see what you can do. Thank you so much for being here, and we'll see you again. Hello, this is Jace Fugate here with the Introduction to the Go Programming Language. So today we're going to be talking about Booleans. So Booleans are true and false. There's only two different ways you can go, but they are extremely used and useful in programming. So let's create a new package. Let's call it bool. Inside here again, we'll make a main.go. Package main. Let's create our main function. So let's make a new variable here. Var true. This is a type bool. True. True is all lowercase. Boolean, true, and false are all lowercase. We can do some type inference here if we want. Let's just say false. It knows that false is a Boolean, so you actually don't even need to put the type. So there we go. We got two variables. We got true and false. Something else that you can do is create a new variable and do a comparison. I'm gonna call this C true for comparison true. Let's say that 10 is greater than 9. So that's true, right? That's also true. That's also true. So you can use the comparisons that you know of to evaluate into Booleans. Let's say here, 10 does not equal to 10. So that's false. 10 does equal 10. So this will come out to be false. And then you also have operations. You have and or. And there actually is an order of operations you can kind of think of with ands and ors. So let's say we have I don't know, 10 equals. So it's not a single equal, it's double equals for a comparison. And 1 is less than 10. That'll be true, right? Because both 10 is equal to 10 and 1 is less than 10. Something that's interesting about the AND operator, I'm going to do another one here. I'm going to do AND false. So if you were to put here 10 is not equal to 10 and 3, I don't know, is less than 6. So 10 is equal to 10, right? No, 10 is not equal to 10. And so Go actually just short circuit right there. It'll say, hey, 10, it is equal to 10. You're trying to put an AND operator here, so I don't even care what this other thing says because I already know that's false. So it'll actually short circuit ANDs. Let's do an OR. So this is two statements as long as one of them is true. So let's say, in fact, we can even just put in true or false. This will be true, right? Because either this thing is true or this thing is true. You could put in here see 5 is greater than 0. So 5 is less than 0. So this would actually, it would be true. Even though this is false, it doesn't matter because one of these is true. And the order of this does not matter. So you could do this and this would still be true because one of them is true, one of them is false. For something that uses an OR operator to be false, both things have to be false. So let's say 100 is less than 0 or 100 is less than 0. So that's going to be false, right? Because 1000 is greater than 0 and 100 is greater than 0. So you can use these, and we're going to use these a lot in conditionals or if-else chains. We're going to talk about that in another session. Let's go ahead and print these out. So in the other sessions, what we would do is we would actually use the format strings. What we're actually going to do this time, we're just going to print them out. Go is smart enough that it will take whatever you give it when it comes to printing and just do the best job that it can. There are some caveats to that, using like custom structs. That's a topic for another time. If you are using custom structs, you can make a stringer method. We can talk about it another time. So let's go ahead and give it a bad name. I wish you guys were here. You could have corrected me. Everyone makes mistakes, right? So let's clear this. Let's cd into our new package here. Go run. There we go. True, false, true.
Thanks for watching. Please like and share this video.
False, true, false, true, false. So it prints it out and actually just says true or false. Booleans are hard. They seem really simple. You have some comparisons, you have two values, and an OR. But they can get really complicated, especially once you start throwing variables into it and just start throwing other things into it. It can be really hard. Take Booleans slow. Really try to understand them. There will be some course material that goes farther into this topic, but play around with it. See what you can find. See what kind of combinations you can make. Thank you so much for being here. We'll see you again. Hello, this is Jace Fugate with the Introduction to the Go Programming Language. Today we're going to be talking a little bit about the complex numbers in Go. So I went ahead and made a new package called complex in my source directory. I made a file called main.go, created my package, did my imports, and I have my main function. A little disclaimer here, I don't know personally complex numbers really well. I'm not a mathematician. When I am programming, I'm usually doing microservices that are doing network type of stuff or telecommunications. And so I just wanted to have this right here in front of you. We can go through these comments together. So when you create complex numbers, there are two complex number types. You have a complex 64 and a complex 128. They are similar to float 32 or float 64 numbers, but they take into account the imaginary aspect of numbers. And so here we explicitly made a complex 64. And then here we have complex number with, as you notice, the I that comes from mathematicians. They're smart people. And right here we used type inference, and that defaults to a complex 128. And we'll print that out. In fact, I'll go ahead and run this just so that we have it right here below. So I went ahead and ran that. So here we have it. Here's X and Y. Remember for your math classes how you print those out. And so here we cast these two numbers to a complex type. We have 4.5 and 7.1. And we put these in, and when we print it out, you can see here 4.5 plus 7.1i. And here's some of the operations that you can do with complex numbers. So here we have a 3 plus 5i, we have b equals 2 plus 4i. And let's do a whole bunch of operations. We do plus, minus, times, and divide. Go handles them all quite well. And you can see this is how it prints them out. So there's going to be more information about complex numbers in Go and your course material. Thank you so much for being here. Definitely play around with these. Have fun with it. I hope to see you again. Hello, this is Jace Fugate here with the Introduction to the Go Programming Language courses. So today we are going to be talking about strings. Strings are great. Strings are a string of characters. That's where that comes from, a string. Strings, think of them as words. We always put double quotes in Go around strings. Let's go ahead and create a new directory. It's called the strings main.go. Create our main package. Create our main function. So let's create a string here. Let's use type inference, in fact. Let's not even tell it that it's a string. We could. We can use \t for a tab character we wanted. You can't actually put a tab character in. So let's see. Let's type in something. Put another tab if you wanted. If you want to put a new line character, you have to use \n. You can't just put like a new line character, that the Go will get mad at you if you try to do that. If you want to be using a new line characters, you can do that actually, but you have to use a back or a backtick. So let's type this in here. So I just had this on my clipboard so I could type it quickly for you guys. But we've got some tab characters, and I've read a line. I have some new lines, some tabs. Write some more stuff, new line, tabs, write some more stuff, a tab character, and a new line there at the end. Let's just print this out. We'll just let you see what it looks like. So as you're following through with this, definitely just play with it. You will learn best if you just experiment. See what changing certain things does. There goes auto import my fumped package. Again, if your editor does not do that, you're gonna have to just do that manually right here. The fumped, import fumped or input FMT. Let's run this. So you notice when I use those backticks, it looks pretty right here, right? It doesn't look so pretty right here. Didn't do what we expected. Right here it added those tabs in, and it added a new line. But when we use these backticks, everything is literal. This is called a literal string. This is just a regular string. This is called a literal string. It will literally print out whatever you put in it. Even if you put in that special new line character, no matter how many backslashes you put in there, it will just print out whatever you have. So if you wanted this to print a little bit better, you would have had to put the you could put the space up there if you wanted. Of course, then you would have a new line at the beginning of your literal character or your literal string. So if we wanted it to print out with just new lines, and we wanted to be lazy and didn't want to actually put in there we go. It's a little bit better. But again, I gotta put a new line here at the end. So literal strings are very useful when you have a complex string and you really just want whatever you type in there to be in there. Run that again. There we go. Oh, I forgot to save it. No wonder it didn't put my new line. There we go. It's always useful to learn the clear command in the terminal. Just kind of clear up all the kludge. So there you have it. A string with a double quote. Again, not single quotes, double quotes. And you can use \t to \n. If you want a literal string, so you don't want any escaped characters, you can use a backtick. But you have to remember that when you use that backtick, it literally takes whatever is inside those backticks, even if it's at the beginning or the end, it will literally take whatever it is that you put in there. Here's a new line right there because there's a new line right there. So play around with it, see what you can do. Thank you guys so much for being here, and we'll see you again. Hello guys, this is Jace Fugate again with the introduction to the Go programming language. Today we're going to be talking about type conversion. So I went ahead and typed this up just so we can have it right in front of us. If you need a refresher, you want to just create a new package in your source directory, main.go, create your main package, import your fumped, make your main function. Well, we're going to do a little bit of type conversion. So we started off here on line 7. We have a int64 that is the number 4. And then down here we make b, that's an int, and we want it to be equal to a. Let's say we want b to equal a. This wouldn't work. If I were to run this, in fact, you don't even have to run it. It will just tell you, hey, I can't do that. A is a type int, and you're trying to use that as a type int 64, and you're trying to use that as an int. We can't do that. So you have to convert it and say, hey, I actually want a to explicitly be converted into an int. Down here, we have a float 64, 6.5, and we want to do some math with it. So let's say we want to add it to our now int. If you were to do this, just by itself, it'd be mad at you. Because it says, hey, invalid operation, b plus c, mismatched types here. We have an int and we have a float 64. We can't do that. And so you can just type here, float 64, and say, hey, I actually want this integer to be a float 64. You can do that. You could, I guess, also cast this over on this side as an integer, and that would work as well, but you would lose your 0.5 precision. You would lose that decimal precision. That works just fine. You can print that out. Let's just go ahead and print it out. Yeah, let's do that. Jump into the correct directory. Make sure I'm there already. So you have 1.5. And so let's convert some more stuff here. So we have the integer 65. Well, we want it to be a unsigned integer. You can just do that same thing. myUint, just like the type that you want. Put myInt in there and it will convert it. If it can't convert the type, it will give you an error. And so if you're trying to convert, I don't know, again, if you go to structs, we'll talk about structs later, but you try to convert like a struct into an int, it's probably not going to work out too well. You can convert now myInt to a float, and you'll get it just fine. So let's change this println from, instead of just printing out the number, let's do a printf here. And let's do a %t for all of these. This will print out the type that we have. Oops, forgot a comma. Let's print out the type. Look at this, see? It's the same number as the 65. And here, let's 65, 65. But we're doing the type conversion. So when we print out the type, it says, yep, we have an int, a uint, and a float. Little heads up, don't get this confused with a lowercase t. That is to format booleans. Uppercase T for types. So there you have it. That's the basic idea of how type conversion works in Go. Thank you guys so much for being here, and we'll see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So today we're going to be talking a little bit about something called constants. So constants are the same basic idea as variables. There's only just a couple differences with them. First thing is variables are variable, as in they can change, and then constants are constant. They don't change. Once you set them, they stay the same. So let's go ahead and show you the syntax that we use to create constants. The keyword will be const, C-O-N-S-T, space, the name of the constant, the type, and then equals, and then the value. So this is almost identical to how you create variables, except for instead of var, use const. Similarly, you can use type inference if you wanted. You could do myStringConst2, and this time I'm not going to put explicitly what the type is. In fact, let's do an integer. Go will just infer the type. As well, you can do syntax where you use the parentheses, and you can create multiple constants all at once. So, ooh, that's kind of a misnomer there. Let's my float. In fact, I'll just do this. What's another type? I guess we could use a rune. There you go. And let's go ahead and print these out so that we can see them. You'll notice that when I print them out, they will print out just the same as a variable would.
Thanks for watching. Feel free to add your questions as comments down below.
There you go. So let me cd into the correct directory here. You just gotta check the directory you are in. So I'm actually in the constant. Everyone struggles sometimes. Sometimes I struggle more than other times. There we go. Let's go ahead and clear and let's run this again. I apologize. There we go. String 1, 1.2, and 114. So one thing that you cannot do with constants, as I talked about before, is you can't change them. So if I were to, after this print statement, say, hey, I actually want my string const to be changed to hello, and I try to save that, it's going to yell at me. My linter or my text editor will even say cannot assign to my string const. If I try to run it, the same thing's going to pop up. Cannot assign to my string const. My string const has already been declared and set, and because it's a constant, it's immutable. You cannot change it. One thing that is useful with constants, the thing that I usually use them for, is at the outside of the main function, or outside of any function, I will create a bunch of constants that I will use throughout the package. It could be something like the base URL. Maybe I'm going to be doing a bunch of network requests. So this will be the base URL that I'm going to use. Okay, or maybe you're doing a game or something, and so it's going to be, I don't know, like the block size. And that will be 10. And something that you'll notice is this doesn't yell at me at not using them. So if I were to get rid of this print, other than the fact that this is yelling at me because I'm trying to redeclare, it doesn't actually yell at you. With variables, you have to use them if you declare them. Constants are not that way. You will notice I always use the const case when I create my constants. If I'm creating them outside this block, const case means it's all capitals with an underscore in between. Go is very opinionated, and if you have the Go tools hooked up to your linter, you'll see little yellow squiggles or something that says, hey, you don't use all caps, use camel case. The Go idiom or the Go convention is to use camel case with this. I will say that I prefer const case, but that is just a personal preference thing. But just if you're wondering if why you always are seeing squiggles whenever using different cases and such with constants, that's why. Go just is very opinionated and gives you a lot of suggestions on how you should write your code. One other thing I should also note is you cannot use the short syntax to create a constant. You can't use like the colon equals when you're doing a constant. That will create a variable. That will not be a constant. That syntax always creates a variable, not a constant. Okay, there you have it. So definitely play around with this. See what you can and can't do with it. Again, it's very similar to variables, but there are some differences. There are some nuances with it. So become familiar with those differences. Thank you so much for being here, guys, and we will see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. So today we're going to be talking about if statements. What an if statement is a way to control the flow of your program. It allows you to tell the program whether or not you want a block of code to run or if you want it to not run. It's one of the couple control flows that Go has. And so you have here the basic syntax of a if statement. You have if space a condition that can evaluate into a Boolean. We're going to be doing Booleans here, so true and false. And then you have parentheses, some code inside the parentheses. And so I'm going to go ahead and save this, and you're going to notice that my code editor actually gets rid of those outside parentheses. So something interesting with Go is that the parentheses, the outside set of parentheses, is not required in an if statement. This is different than in some languages like JavaScript, where you have to wrap the condition with an outside set of parentheses. In Go, you don't have to do that. Parentheses can still be used to control the order of evaluation, but again, you don't need any on the outside. And so let's go ahead and run this. You'll notice that 25 is a multiple of 5. So this went ahead and this printed out. Because if you take the modulus of 25, and that would be you divide 25 by 5 and then you take the remainder, well, the remainder of this does equal 0. If I were to change this to 26, this would evaluate to 1, which is not equal to 0. So we'll go ahead and run that. You notice that nothing prints out this time. We'll go ahead and jump to another example here. So again, as we said, the parentheses are optional. You don't need any parentheses at all. We'll go ahead and run this, and it says -1, or that -1 is negative, and that's true. -1 is less than 0. I mean, this, when it evaluates, is the same thing as if I were to just straight up put in true. If I were to switch this around, it would evaluate to false, and it would not run. Because now I'm saying that -1 is greater than 0. That is not true. And so it skips this whole code block. And you can create very complex evaluations. And you can use order of operations if you want. So and then you could run this. We can find out if that's true or false. There we go. I'm going to go ahead and clean this up. And then you also have and or operators. You may remember these when we were going over Booleans in one of the previous sessions. And let's go ahead and run this. And this will come out as true. I'm going to clear this and bring this up to the top. Comes out as true, and it prints out my age is between 17 and 30. So the and operator, what it does is it looks at the evaluation on the front and it looks at the evaluation on the back. And if both of these evaluate to true, then the whole of it evaluates to true. And then this whole code block will run. You can also use an or operator. And when we run this, it will give us the same output. And this is just saying, hey, if this condition evaluates to true or this condition evaluates to true, then all of it is true. And it will print out the code, or it will run the code block. Something that's interesting about the and operator is that it will actually shortcut, as it says here on this comment above, it will actually shortcut if it finds out that the first one is false. So I'm going to just change this so we don't get confused. And so if we change this to a less than or equal to, this will evaluate to false because 21 is not less than or equal to 17, but this is still true. We'll go ahead and run that. You notice nothing happens. And what Go actually did here is it didn't evaluate this and then evaluate this. It actually just said, well, this is false, and then, oh, stop, and operator. That means both of these have to be true, so I'm just going to bail out early and just continue through. It's just nice to know when you are doing more complex conditionals in your if statements, to know that if this evaluates to false, this won't even run. Again, if we were to use an or operator, this would actually print out. I'm going to change this and say or. This would print out because, well, this is false, but this is true. And for this whole entire statement to be true, only one side has to be true. Both can be true or one can be true. Either way, or is happy. Let's go ahead and move on to an interesting syntax that Go has. This is the short statement, or what you call a short statement. And so what it actually does here is it has two parts. It has an initialization of a variable, And then it actually has the condition that will evaluate to either true or false. And this is the same as if we were to do this right here. And then we just got rid of this initialization. The only difference is it's instead of 2 lines, it's only 1 line. That is nice. You're saving on lines of code. And as well, and this is something we'll talk about more in the future, is it actually changes the scope of n. So n is actually not available outside of the if statement. I'm just going to go ahead and show you the error that it will give me. If I try to use it, it'll yell at me here and say, hey, n is undefined. We'll talk about that more later when we go over variable scoping. But it's nice to use so that you can keep this variable only inside your if statement if you don't want it to bleed out. So we'll go ahead and run this, and it evaluates to true. 10 is even. So you do a modulus of 2, or 10 mod 2 is equal to 0. We could change this and do an 11. This would not run. So there you have it. That is the basic rundown of the if statement. If statements are extremely important, and they can be very confusing. Even though I've been in the field for a pretty good while, I still get confused with complex conditionals. Because, I mean, they can get pretty big. And sometimes those ors and ands and greater thans and less thans can get confusing. So definitely take this slow and practice as much as you can with them. Really get comfortable with being able to read a conditional and know whether it's going to be true or false. Thank you so much for being here, and we will see you again. Hello, this is Jace Fugate here with another session of the Introduction to the Go Programming Language course. So today we're going to be talking about if, else, and else chains. So as we talked about before in the previous session, we talked about if statements. So if statements are a way to control if code runs or not. You have the if, and then the condition, and then the code block. Well, what if you want something else to happen if this is not true? Well, you can actually put on an else if right after the closing curly brace and say, well, if this isn't true, this evaluates to false, or it's just more specifically, if this evaluates to false, well, then check this and see if this is true. If this first one evaluates true, it will skip everything else and jump straight to the bottom. And the same thing with this. So if this evaluates to true, then this code will run and the rest of it will be skipped. But if this evaluates to false, then this will be skipped, and it says, oh, hey, there's another condition, there's an else here. And it will run and it'll check this condition. And again, if this is true, then this code will run and it skips whatever else is on the chain and jump down to here. If this is false, then it'll move down to the next one. And then this time we actually have an else. And so basically, if any of these are false, this will always run. So let's go ahead and run this. Oh, don't forget the period, right? So this says your weight is normal. So 21, let's run through this here. 21 is greater than 18.5. So we can basically say, okay, forget about that. We'll move on to the next thing. Well, 21 is greater than 18.5 and it's less than 25.0. So if that's true, it will run this statement right here. And because this statement ran, it ignores everything else. And then it just does it. If we were to change this, now let's put this to 35. Let's run this. Now it says you're obese, so your BMI classifies this as obese. And so 35 is greater than 18.5. So this is false. Skip that completely. Well, it is greater than 18.5. So that's okay. But you move on to this side. Well, it's greater than 25. So this can't be true. So we skip that and say Oh, hey, there's an else if. So
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
check this condition. Same thing. Well, it's greater than 25.0, but it's also greater than 30. So this can't happen. Skip this. I'm gonna say else. Oh, well, that's the last thing we can do. So we just go ahead and run that last statement. Else if chains are great for doing comparisons like this. You can just put in all your conditions in one place, and then you have that. You can add the fall through here at the end. You don't have to have this. You can just get rid of that. If we were to run this, nothing would print out here at the bottom. And something to note is the else statement always has to go last. You cannot put an else if at the bottom. It's not going to like that. It says unexpected else at the end of a statement. Once you do an else statement, that is the end. This is the default. If nothing else evaluates to true, it will always run whatever is in this code block here. So let's play with this. Let's change this to weather. And we'll say sunny. So if weather equals rain, we'll say bring a umbrella. And then we can say else if weather equals sunny. We'll say, hey, if it's sunny out, you should probably wear a hat or wear sunblock. Let's do that. Else. Our program is not going to be too smart. It only knows what to do if it's rain, if it's rainy or sunny. If it's anything else, I don't know what you should wear. So let's go and run this. So it says, well, it's sunny because weather equals sunny. You should wear sunblock. If we were to change this to rainy, it would then tell us, hey, we should probably bring in an umbrella. 2 L's, right? I'm a code instructor, not a spelling teacher. And if we put on here, it is hailing, our program will not know what to do, and it'll just say, I don't know what you should wear. And it'll just fall into the else statement. So play around with this, have fun, and get comfortable with how you use if, else, if, and else chains. And figure out what you can't do with it, I guess, is another thing you should probably figure out. Make sure that you understand that you cannot have it set up this way, right? This is bad. It won't even format my code for me. It says that's not available. So thank you guys so much for being here. We will see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. So today we're going to be talking about switch statements. And in the next few sessions, we're also going to be talking about different ways that you can use a switch statement. So this first type here is just your standard switch statement. This is going to be a control flow similar to an if, else statement. And so you have the keyword switch, a space, and then you have some kind of expression. Here we're just using a single variable. You then have curly braces to say here's a code block. And inside this code block you have some cases. And so you have your first case, and here we're saying if day of week equals 1, colon, run this. If it equals 1, it will run this, and just like in a if, else, if, it will skip everything else and jump to the bottom. Then we have another case, well, if this is equal to 2, then run this. and it just continues to go through. If it's 3, if it's 4, if it's 5, if it's 6, if it's 7, and then we have a default here, and this is similar to the else statement. If nothing else evaluates, then it will run this default. You do not have to have a default, and also you don't have to have these in order. We have these in order just the way I wrote it as I went through, and as well you can use any type of variable. You don't have to use numbers. You can also turn all of these into a string. And now it'll just check to say, hey, does this variable equal the string 1? It's type safe. So if you were to try to say, hey, does this string equal a number? It will just yell at you and say, hey, you can't do that. This untyped int, it's untyped int and a string, not the same thing. So let's go ahead and run this. You'll notice that it says Saturday, weekend, yay. Because 6 goes with this case, runs this code block. You'll notice here that we have some curly braces here. These are optional. You do not have to have these. We just want to put them in there to show you that you can have them if you want to have them, but they're not necessary. You could put curly braces around this statement as well if you wanted, but you don't need it. If I run this, it'll run just fine. We can go up here and we can change this to 1 and it'll say it's Monday. Now if we change this to 10, it'll say invalid day. That's because it doesn't equal 1, 2, 3, 4, 5, or 6, or 7, and it hits that default and it just runs the default case. Again, we don't have to have this default case. If I were to run this now, I'm going to clear. If I were to run this, nothing would print out because none of these cases would be true, and it would just skip it basically. So there you have it. This is the basic usage of a case or a switch statement with cases. Very similar to an if, else, if chain. It is just a lot clearer. Most people will agree. Not everyone will. I agree. I think this is a lot clearer than having an else if and say, if day of week equals 1, do this. Else if day of week equals 2. It's also less typing. You don't have to type day of week so many times. And if I remember correctly, the compiler will actually optimize this, and it will be a little bit faster. Little bit. It's probably marginal. I could be corrected on that though. So thank you very much for being here. On your own time, practice this and get comfortable with it. And in the next session, we're going to be talking about some of the other ways that you can use switch statements. Thank you so much again, and we'll see you again. Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're going to be talking about another way that we can use a switch statement. And so here we're going to be combining things and compressing the switch statement down a little bit. So this is a similar statement as the last one. We're doing a day of week, and we have some cases on that day of week to see if it's a weekday or a weekend. Instead of being Monday, Tuesday, Wednesday, Thursday, Friday, and valid day, we're just going to be doing weekday and weekend. And we also do something similar to the short statement with the if that we had, is we have a variable that gets initialized, a semicolon, and then the statement that we're actually going to be checking in our case. Similar to that short statement and the with the if, same as doing this, but it saves a line, and for some people it's actually more readable. Something else that we did here is this case, instead of just being 1, 2, 3, 4, and 5 in separate cases. So we could have written this all separated out like this and so forth. So then I would separate 2 and 3, 4, 5, all to separate cases. We can actually just combine them all into one and just say if it's any of this right here is any of these, print this. If this right here is any of these, print this, and then our else or our default print this. Let's go ahead and run this. It says the number 5 of the 5th day is a weekday. So we can change this to 7. Weekend, we can change it to 1. I'll say weekday again. So something else I'm going to show you here is the fall through statement. It works similar to this, and I guess you could use it in a similar way. If you wanted to, you could actually do this. You could say, hey, if it equals 1, fall through to whatever case is underneath. So it says weekday. If we wanted to, we could have this print out something first. Monday, it goes Monday, hits the fall through, and goes right into the next case. This may seem a little strange, but there have been many times where it's actually been useful. I will say though, don't try to force this. There are just some cases that you'll find yourself coding something and just thinking to yourself, well, if it's this one case, I wish it would also do this other thing. So there are many ways to be able to combine and compress your switch statement. And you should definitely play with them. See what you can do with it. Again, see what does and doesn't work. And you'll be able to put this in your tool belt as something that you can use as you go out into the world and develop. Thank you so much for being here, and we will see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. Today we're going to be talking about switch statements again. We're going to be continuing what the last 2 sessions covered. And so with this switch statement, as you notice, there is no evaluation, or there's no condition here. There's nothing to evaluate. So what this does is it tells the switch statement to just look at each case and look for truthiness. And so this is the same as doing if this, and then else if this, and then else. Some people like to use the if statements, and some people like to use switch statements. It just depends on your own personal choice, what it is that you think looks more readable. The reason why Go does this, I feel like, or at least the reason why you choose one over the other, again, is just so it's more readable. In many instances, and in fact, I would say in most instances, readable code is better than slightly more performant code. So if you can do anything in your power to make your code more readable so that the person behind you, the next person to come and try to figure out what your thing is doing, has a little bit of an easier job doing that, it's worth it. It's do it. And that person that comes behind you to try to figure out what your code does, well, it could be you. I've done this many times where I've written some code and 2 years later I have to go back to it because it turns out it has a bug. Something was wrong with it and I don't know what it does. And I have to take a couple days or a day or a couple hours to figure out, well, what does this whole thing of code do? And then I can go and fix the problem. And so if you think, especially if your team thinks that this is more readable than doing something like this, this will seem very similar, very familiar to you if you've seen the last session, because it does the same thing as that else if statement. We'll end it with the else instead of a default. And that will run just the same. So we can do a go run, wait as normal, and I'll go ahead and switch this all the way back to the switch. And you see the same thing comes out. So there you have it. You can use a switch statement without.
Thanks for watching. Please like and share this video.
A condition here, and just use it as a truthiness check. Thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're going to be talking about for loops. So loops in general are ways that you can encode, run the same piece of code or same block of code multiple times without having to copy and paste. Loops are great because it gives you a way to dynamically repeat code. It's just a lot more flexible than just copy and paste. Something that's interesting with Go is Go only has one keyword for loops. It just has a for loop. It just has for. It doesn't have a do, it doesn't have a while, it doesn't have a do while, none of that. Just one for statement. And let's go ahead and show you the syntax. And so the full syntax for a for loop has three parts. You initialize a variable, you have a conditional check, and then you have a statement that runs at the end of each iteration. And then after those three statements, you have opening and closing curly braces, and then you have some code inside. Here we're just going to print out I is equal to whatever I is. Let's go ahead and run this. As you see here, I've actually already run this code. Let's run it again right here in front of you. We should probably put a new line on the end here to make it a little bit more readable. So there you have it. It prints out I is equal to 0 through 9. So let's run through this code. So the first thing it does is it initializes I to 0. It then checks to see, well, is I less than 10? If that is true, it runs the code block. After the code block, it runs this third statement, which will increment I. And then now check again, is I less than 10? If that's true, it'll run this code block. And then it will run this statement. And it keeps doing that. So the first time, I is 0. Well, 0 is less than 10. Runs this, and now runs this right here. And then it runs the statement, which says, now I is equal to 1. So it was 1 less than 10. It runs. Well, then increment it to 2. And that checks again. It does 3, 4, 5, 6, 7, 8, 9. And on the 9th run, it checks. It runs this. It increments 9 to 10. And then it says, oh, well, I is less than, or 10 is less than 10. No, it is not less than 10. It skips and jumps through and moves on with the program. Something that's very useful in Go is you don't actually have to have this first statement. If you wanted to, you could just do this. You leave the semicolon there, and then you can just say, and you can initialize your variable. You could do stuff, and then you can then run your loop if you wanted. And that runs just fine. As well, you could pull that statement off completely, so you just have your conditional. When you just have the middle statement or just have the conditional, you don't need the semicolons. So then you can just have your conditional down here, and then you can run this. Same thing happens. Or I guess if you wanted to, you could pop this here, put a semicolon at the end, and then you can do the same thing. And so you don't have to have all three statements directly right after the for. You can break it up if you want. But again, if you're going to have just two of them, it's either going to be the first and second or the second and third. If you have two of them, you have to have the semicolons. If you're just going to do the conditional check, then you don't need to have the semicolons. Something else to note is you do not need parentheses. Some other languages require you to use parentheses, just like if statements. Go, you do not have to do that. So again, for loops are extremely useful, and it's the only way that you can really repeat code in Go. And you can use the same for loop in many different ways. Thank you so much for being here, and we will see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. So today we're going to be talking more about for loops. We're going to be talking about the infinite for loop, and then we're also going to talk about two other control statements that you can use within loops. So I already have my project set up here, and I'm going to uncomment this infinite for loop. Let's go ahead and run this. You'll notice that it keeps printing out the word infinite. And it does exactly what you would expect. For, and it just keeps going. In some programming languages, this is a no-no. You don't want this to ever happen. But in Go, because these are used for a lot of long-running programs, this is completely acceptable if you're using it on purpose. So infinite loop will just continue to keep running and running and running and never stop, unless you were to put in a break in there. So let's run this again. You'll notice this time it's only going to happen. It's only going to run once. It'll break and then it'll continue through. And so a break statement breaks out of a for loop. We have another example here below of how you can use a break statement. So in this case, we have num gets initialized to 1, and we want to do this loop as long as num is less than or equal to 100, and then we increment num each iteration. Then we have an if statement here, and we want to say, hey, is the first positive number divisible by both 3 and 5 is. So do a check here. We say, hey, is num divisible by 3? Or you could also say num mod 3 equal to 0, or num mod 5, or is this number divisible by 5. If this condition evaluates as true, we print, and then we just break out of the for loop. Let's go ahead and run this. So we'll see it says the first positive number divisible by both 3 and 5 is 15. And so this for loop happens and just keeps chugging along as you would expect until this break statement runs. And once that break statement gets hit, it immediately jumps out, just like we saw in this infinite for loop. It immediately jumps out and continues down the rest of the program. So a break statement does exactly what it says. It breaks out of a for loop. Now we have another control flow keyword called continue. And so this has a familiar for loop. It's num is equal to 1. We run this as long as num is less than or equal to 10, and then we increment at the end. We say here, well, if num is divisible by 2, or if num mod 2 is 0, we continue. What continue means is we skip everything else and we just go straight to the statement and iterate again. So let's go and run this. There you go. It printed out all of the odd numbers between 0 and 10 exclusive. So it prints out, or I guess I should say it does 1. Well, num mod 2, sorry, 1 modulus 2 does not equal 0, so it does not run this and it prints. And it goes, increments num to 2, and now 2 mod 2 is equal to 0. You hit this continue, you skip everything else, you go to the next iteration, and it runs through. So continue does exactly what it sounds like it should do. It continues the loop and skips everything else after it. Very similar to a break statement, except for a break statement breaks out of a loop completely and skips everything else behind it until it gets to the ending of the for loop and then continues through. So if we run both of these, we'll have the first positive number and then we have all of the odd numbers. So here are just some of the other ways that we can do some control flow within for loops. Play with this, see what you can, see what you cannot do with this. These are very useful and can help you solve some pretty tricky problems. Thank you so much for being here, and we'll see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So today we're going to be introducing functions. You've seen functions, or you've seen a function, because in every Go package that's going to be compiled down to a binary, you always have a main function. And so all functions have or follow a similar syntax. So let's go ahead and do something here. Let's say we have a variable a equals 10 and then variable b equals 15. And then we want to say that c equals b minus 10. And then we want to print out the difference. Well, as it notice here, I did not define C. I have to either use var or I need to use the shorthand syntax. So I'll go ahead and do it that way. So let's run this. Prints out 5. That's kind of what we expect. Well, what if we wanted to use this kind of a thing a lot in our program, but we didn't want to always have to explicitly do this subtraction? Or if maybe down the road we have a lot of this subtraction, but we realize we actually want to add something else into this equation. Well, let's break this out and make a new function that will do that subtraction for us. So I'm going to make a function called sub. So func space sub parentheses, and this time, unlike the main function, we're actually going to put something here. We're going to say a, and we'll take an integer, and then b, an integer, and we will return an integer. So again, let's go over this again. So you have func space, the name of the function, the parameters. We'll talk about what these parameters are and what they do. But the parameters, these are things that we can use within the function that come from somewhere else. And then we do a space, and then we say, well, this is what we are going to return. This is what this function is going to give back. And then some curly braces. So let's say return b minus a. Now we can actually replace this with sub, put b comma a. Let's go and run this, and I'll talk a little bit about how this is working. Oh, I got that backwards. Let's go ahead, just so we have the same thing coming out. So we have 5. So what this did is we made some reusable code. So anytime you call sub and then pass it 2 integers, because that's what this wants, this will then run whatever code we have in here. And in fact, let's do this. So we run this code, set it to another variable, and then we give that value back. And it is an integer. This is typed, which will then equal, we can make C equal whatever sub returned. It's important to note that this is typed. We cannot put in a string here. It'll yell at you because it says this function that it takes an integer and an integer. We gave it a string and an integer. That doesn't work. As well, we cannot pass something else back that is different than what we said we would. This is going to yell and say, hey, you can't use hello. It's a typed string, and this is supposed to return an integer. Functions are extremely important. You do not want to make one giant program just inside your main. You want to be able to break this out so that in the future you can test things easier, and it's just a lot easier to read. You can give these functions good names. You wouldn't want to call this add, because then that would be incorrect because it actually subtracts. You want to give your functions good names so that you can organize your code and reuse your code. So what if this sub function, if actually every time we wanted it to subtract, we also wanted to subtract an extra 2. We could do that. But if we had this b minus a throughout our whole entire program, we would have to go through and try to find every time it runs this and put another thing on there, another minus 2. Functions are very useful. You can call functions within functions if you really wanted to. I'm going to make a function similar to the main function. It doesn't take any arguments, doesn't give anything back.
Thanks for watching. Feel free to add your questions as comments down below.
And let's run this inside here. You notice how I'm not returning anything, and I'm also not capturing the return in any variable because you don't have to. Let's run this. Here you go, ran thing. Let's put a new line on the end of here and make this a little more readable. So you can call functions, that can call functions, that can call functions. Thank you so much for being here. We'll be talking more about functions in the next session. We'll see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. And so we're going to be continuing the last session's topic and be talking about functions. So here is a little bit more complex example of a function. And so let's look at this. Let's start here with the main function. We initialize two variables, and these are initialized to floats. We then call this function right here and pass it those two floats. You notice here, this is typed two floats. We did something a little different than last time. Before we had the types after each variable or each parameter. If you accept the same, like two of the same or multiple of the same types of parameters, you can actually omit the type until the last instance of that type. So in this case, this is a float, this is a float. We can just put float here at the end. If we had like a string on the end, you could type that. You couldn't, and then if you were to put this right here, I mean, this is a string, and then this is a float. So again, it just is nice so that you don't have to always put all the types there on the end. Let's go back to what I was saying. So you pass in two floats, you call this function, and then takes the current price, subtracts the previous price, and then it then calculates the percent change, and then returns two things. It actually returns the change and the percent of change. And so if you look at the syntax, we have func space the name, we have the parameters, and then we actually have multiple returns. So you can return more than one value. If you call this though, you have to make sure that you capture both values. You could run this like this if you didn't want to capture any values. But if you want to capture any of the values, you have to put something there to catch both of these returns. We then do an if statement and then check to see if it's been decreased or increased and by how much. Let's go ahead and run this. There we go. We can change this to 1, give a little bit different of a value. Change this to really big value, and notice that it switches. It says it decreased this time. But with functions, you don't have to only return one thing. And also, when you're doing your parameter list, you don't always have to say what each parameter is, the type of each parameter, if you have duplicates or two parameters of duplicate types. You can just put them right next to each other and then indicate the type of the last one. So play with this. Figure out what you can and what you can't do with it. There is no limit that I know of how many return variables. You can put as many in there as you want. But you do have to make sure, again, that you capture those return variables. Thank you so much for being here, and we'll hope to see you again. Jace Fugate here with another session of the Introduction to the Go Programming Language course. We're going to be continuing our discussion on functions. And so in the last discussion, we talked a little bit about multiple returns. And so we're going to be going on that same idea, and we're going to introduce a new type, an error. So in Go, unlike other languages, you do not have try-catch statements. If that makes sense to you, great. If it doesn't, that's okay. but you don't have try, catch, you don't throw exceptions. What you do is you return an error from a function. And by convention, if you're going to be returning an error, you always put that error as the last parameter that you are returning. So let's look at this example. It's just a little bit more complex version of what we were running before. And so we create the previous stock price, the current stock price. We pass those into our function. Our function then takes those in as float 64s. And then we do a check here. We say, hey, if the previous price was 0, that's not something that we are willing to handle. So what we're going to do is we're going to create an error. So we're going to be importing the arrows package. We're going to do errors.new. And then we put in the text that is our error. We save that in a variable called error, ERR. That is, again, another convention that you call your error, ERR. And then you return the default value of floats, in this case 0 and 0, and then you return that error. Else, if the previous price was not 0, then you continue through the function as normal, and you pass something called nil in as the error. We'll talk about nil here in a little sec. So this then returns, we capture all 3 returns in variables. And then what you want to do is you first check if error is nil. If your function or using a function that returns an error, the first thing you do after you run this function is you always want to check if error is nil. And then you do everything else. If error is nil, or if error is not nil, I apologize, I said that incorrectly. You check to see if error is not nil in this case. You then handle that error in some way. In our case, we're just handling the error by printing. And then you continue through the rest of the program. In many cases, you'll see that this will return. So this will just stop the function, or stop the program, or stop whatever function is that you're in. So let's go ahead and run this and discuss what comes back. And then after that, we'll talk a little bit about nil. Let's get into the correct subdirectory here. There you go. Sorry, there was an error. Previous price cannot be 0. If we were to change this to 1, it runs as normal. So let's go to error, or to nil, just for a quick second. We'll discuss nil a little bit more in depth at another point. But we return nil basically just to say there's nothing here. So there is no error. So the default value of an error is nil. You've also may have seen it as undefined or null in other programming languages. In Go, it is nil. And so if you are not going to be returning an error, you always want to return nil. You don't want to do this and return like an empty string or something, because you're going to then check to see, oh, does error equal nil? Well, it does not equal nil, so you'll error out, even though this wasn't nil. This should have been nil. So I'm just going to recap what I talked about here. So you can return multiple returns from a function. And if you're going to be handling an error, so if something in this function can go wrong and you want to be able to indicate that to the caller, you put error as the last return, and then you return an error. If no error happened, you return a nil. And then the caller should capture your error, check first to see does error equal nil or does error not equal nil, handle that case, and then continue on their program however they would like. Thank you so much for being here. We'll hope to see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. And so we're going to continue our discussion on functions. So as we talked before in the last 2 sessions, we're talking about multiple returns. We're talking about the returns of a function. And so this is a similar example, almost the same exact example that we've seen before. Then we have a function that takes two parameters, both of them being float64. You'll remember that we could have done this, but instead, because they're both float64s, we could omit the first float64 and just put that on the end. Well, here on the end, what we had before was this. We had two float64s. But we can actually give them named. These are called named returns. We can go ahead and instantiate a variable at the beginning of this function that says we are going to return these two variables and they're both of this type. If we wanted to do different types, we could do an int, but both are going to be float64s. And so we take the current price and subtract it from the previous price, set to change, same name as this. And then we have the percent change. We do the same equation that we were doing before. And then we return change and percent change. One thing that's really cool about this, in fact, let's just go ahead and run. Let's go ahead and run this. So just a second. So let's go ahead and cd into the correct package. Error fun. Okay. So go run. And so it says here that the price is decreased by 10,000, and that's a 10% of the previous price. So that works just fine. We could actually do this. We can remove the return completely. Apologize. You can remove the return, or keep the return, but remove the things that it returns. Because you've already declared at the beginning of the function, this is what it returns. It's going to return the change variable and the percent change variable. You notice here we didn't have to do var, or we're not doing var. We're not doing the short instantiation of a variable. I mean, we could have done this if we wanted to. We could do var change and then percent change. This is the same as what we have currently. And then change this to just say two floats. And then explicitly return change, percent change. We could have done that. But we can save ourselves some lines by just using named returns. I will give a warning with named returns. If you're using them on a really big function, or maybe a more complex function, you may forget what you're returning, or maybe there's going to be some the stuff in it that makes it a little bit not as clear as if you would have just explicitly returned specific variables. But again, this is a personal preference between you and or the team or the company that you're working with or for. So that's it. That's named returns. Thank you so much for being here, and we'll see you again. Hello again. This is Jace Fugate with another session of the Introduction to the Go Programming Language course. And so we're going to continue our discussion with functions. This is going to be our last video on functions. And so what we are going to be talking about today is this little guy right here, this little underbar or underscore, whatever it is that you want to call it. This is a blank return, or this is just a way that you actually ignore a return variable or return value from a function. So this is the same example that we've been using the past 3 or 4 videos. And it has two return variables, two return values. But in this case,
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
We only care about this return value. We only care about the first return value. Because if you remember in Go, if you create a variable but then don't use it, it'll get mad at you. It'll say, hey, you're wasting this. So what you do to fix this is you put an underbar. And that makes it so that you don't instantiate a second variable. You're only instantiating the first variable and taking the value from the first return and keeping it to use later on in your program. You can do this for either. You can do it for the first or for the second. That works just fine. It'll get mad at here because I don't have the instantiation of change. But you can't do both. If you do both, it'll yell at you and say, there's no new variables here. This would be the same as doing this. And this is what you should do instead. If you want to completely ignore the variables or the return values, you just don't have it equal anything. But if you only want one, again, as we had it set up in the beginning, you just do that. This can be very helpful. One thing that I use it a lot for is when I'm just kind of writing a quick script, is I'll actually ignore the error, because a lot of times you'll have like that error here on the end. So I want the first two. I'm just going to call it a vary for variable, and then I'll ignore the error just because I'm testing. But keep in mind, don't ignore errors in production code. That is bad. But it's something that I use a lot just as I'm running through code, and I want to just say, hey, I'm just looking at this one variable. Let's run through it. Let's run through this code, but just look at this one variable, or ignore this piece here and there. And so there you have it. That is blank returns. I appreciate you being here, and we'll see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. So in the previous video, we introduced the concept of a package. A package is a way that we can take some code, put it somewhere else, and then we can then import that code or import that package and use it somewhere else. So this is the same example. We're going to continue off where we left in the last video. So we had some functions. We had add, subtract, multiply, and divide. We first had them just in this main package, but we decided it was a little bit messy. We wanted to put it into another package, and then we would just import it. And so we moved that into the alg package. All the code here, we moved it into a different package. It's just a subdirectory of our main package right here. Ooh, the main packages package that we have. And so the few things that we're going to be discussing today are private versus public things inside of a package, or exported and not exported. That's the Go terms that are used. And I also want to talk a little bit about the difference between the name of the directory and the name of the package. That can confuse people a lot. So let's first talk about exported and non-exported. So in Go, they do this very, very simply. Basically, if something starts with a capital letter, it's exported. You can access this outside of this package when you import this package in. If it's lowercase, you cannot access it. So let's create some constants here at the top, just for fun. Let's make pi, and we're going to make that 3.14. And then my fave num, and make this 777. So if we go over to the main.go where we were importing alg, where we're importing this, now let's try to print out those two variables that we created, or those two constants that we created. Println alg dot, what was it, pi, right? See, it yells at us. It says, cannot refer to unexported name alg.py. Because pi is lowercase, we cannot access it outside of the alg package. We can't here in the main package, go into alg and have access and be able to print out pi. If we were to change pi to an uppercase letter, then it would be just fine. We could run this and it would work. There it prints out right here, 3.14. Another example is we're going to make add lowercase. So a function, same thing. If a function is lowercase, we cannot access it. It'll say right here, cannot refer to unexported name alg.add. So this uppercase versus lowercase is everything in a package. If it is uppercase, it is exported. If it is lowercase, it is not exported. Something that the Go community and its Go convention as well that they want you to do is that you should always comment things that are exported. So let's put a comment here, and they want it in this format as well. They want the name of whatever it is, a hyphen, and then the description. Let's make something for each of these sub. I'm going to do these pretty simple here. I'm going to put much work into it. Div stuff. And this is really, actually really useful. Oh, we should probably comment pi as well. Because now if we go over to our main package and we hover over, that's right, it'll actually show us our comment that was right above. That is just really nice. So export things, you should comment them so that when you import it from another package, you can get some IntelliSense. And as well, Go will actually auto create documentation. That's a topic for another time. But get in the habit of commenting things, especially if it's exported, so that when someone else imports your package or you import your package, it's a little bit easier to remind yourself what it is that it does. So as I mentioned at the beginning, I'm also going to talk about package name versus directory name. So we have right here the alg directory, and inside we have alg.go. This does not have to be the same name. We could call this functions.go, doesn't matter, and that will work just fine. The name of the file does not matter. But if I were to change the name of alg to algs, put an S on the end, and then try to build this, it'll actually yell at me and say imported and not used, packages alg as algs. So this is the path to the directory that the package is in. But just because the last directory in that path is called alg, or is called anything, that doesn't necessarily mean that that's the name of the package. By convention, the name of the package and the name of the directory should be the same. But this is just a gotcha that you really need to look for. That you will use this package by the name of the package, not the name of the directory. So if I wanted to use this, I would have to access it via algs. And my code editor will actually do a little hint for me here and put it like a tag or an alias at the beginning of the import, so that it reminds me that, hey, this is being imported and used as algs. If you wanted to, you could actually make this label and import this in as whatever you want. You could import it as my favorite package. And then you could even change the name of fumped and change it to format if you wanted to. And now anytime that you wanted to access fumped, you would actually have to access it with format. Anytime that you access algs, you'd actually have to access it with my fav package. And it would run just fine. So this aliasing is a great example of just because the directory is named one thing doesn't mean that's actually how you reference it. The two caveats: the name of the package is actually different than the directory, and or you have an alias at the beginning or in front of that import. These aliases are used and are very useful if maybe you are importing two packages that have the same name, or if you just don't want to type out the entire name of the package. Those are the two reasons why I've used it. So play around with this, see what you can and can't do. Create another package in this directory and try to import it. Change the name of the directory, change the name of the package, try using aliases, and get comfortable with this, because this is something that can be really frustrating that you're trying to build and things aren't building and it's saying, hey, you're not using this, or it's not being imported, or you're using it by a different name or what have you. You just remind yourself, check the name of the directory, check the name of the package, check if there's an alias at the beginning of the import. As well, and another recap of what we talked about here today is exported versus not exported. If something is uppercase, it is available outside of the package. If another piece of code imports the package, if it's uppercase, you can use it. If it is lowercase, it is not. And if it is exported, please comment your code. It will make your life and other people's lives easier. Okay, thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. And so today we're going to be talking about packages. So let's go ahead and dive in. Packages are ways that we can organize our code. So we put a bundle of code that relates to each other into a package. Something that you may have remembered, we've discussed it in some of the other videos, is that the entry point to your program has to be called main, and you have to have a main function. So let's go ahead and run this. Nothing's going to print out. It's just going to compile, run, and then give us a prompt back. Well, if I change the name of this to not main and then try to run it, it'll yell at me and say, go run, cannot run non-main package. You can't have the entry point to your program a non-main package. You cannot compile a non-main package. You cannot run a non-main package just by itself. It has to be main. As well, if I were to change the name of this function from main to mains, it'll yell at me and say, hey, there's no main function declared in the main package. So you have to have both there. But you can have packages that aren't main packages. So let's go ahead and show you this here. So let's make a couple functions. We're going to make a couple variables. Let's do var A, var B. And we're going to make some functions, and it's going to be like some arithmetic functions here. We're going to do like func add. I'm going to take A, B. Those are both going to be integers. And then that will return an integer. It's going to be A minus B. I'm doing this quick here, so we can just run through. Subtract, multiply, divide. So it's add, subtract, multiply, divide. One thing that's great about this code editor is it will format that for me. In fact, I like my code to look a certain way, so I'm going to format it a little bit more. Here we go. We have these three functions, and now let's import in the funct package. We're going to print out these functions here. So let's make 4 of these. Make sure we use the correct package name, not funct. It's funct. I love multi-cursor. If your editor does not do multi-cursor, you should find one that does. And if it does do multi-cursor and you don't use it, you should start using it. It's very useful. Let's go ahead and run this. There you have it. 3, -1, 2, and 0. Let's make this a little bit more obvious on what it's doing. Something that you've seen probably in the other videos, anytime I've ever used println or just print, it's always just been one thing I pass into this function, but you can actually pass in as many things as you want and just separate them with a comma, different parameters. And when it prints out, it will print out just with a space in between. So there you have it. We have really simple functions. But what if we don't want these like arithmetic functions to clutter up our main package? We want the main package just to be like the setup, and that's it. So we can create a sub package or subdirectory in the package that we're currently working in. So the package that I have, it's called packages. Inside that,
Thanks for watching. Please like and share this video.
That directory, I'm going to make something called alg. It's going to be like for algorithms. Create a new file. You don't have to call this main.go. You can call it whatever you want. I'm going to call it alg.go. And I'm going to name this the same name as the directory. It doesn't have to be, but by convention you really should. It makes things a lot easier. Let's go ahead and move these functions in there. So now if I try to run my package, it's going to yell at me and say that, hey, these functions aren't defined. And it's true, these functions aren't defined here. They're not here anymore. We don't have access to them, but we can. We can import the alg package and gain access to all these methods. So we're going to be doing multiple imports. And what we're going to do is we're going to first put in the name of the package that we're currently in, because we're going to be basing this path. We're going to be actually building like a path here of where this package is that we want to gain access to. So we start at source, and it's inside the main, or it's inside the packages directory. And then inside the packages directory, it's in the alg directory. And then we reference it based on the name of the package that we're importing, alg. So I'll go over that again. So packages is the name, is the first subdirectory underneath source. And then alg is the subdirectory underneath packages. And then inside of alg, we have the package that we want to gain access to. And so we have add, subtract, multiply, and divide. And by referencing alg, the name of the package, dot whatever function is, we now can run this, and there you have it. It runs just as it did before. So that's a basic introduction to packages. Packages are really nice so that you can separate your code and make it a little bit easier to read. You can do something called separation of concerns. Some people will call it that you put things that are similar in a similar place and things that are different in a different place. So definitely play with this, see what you can and see what you can't do. We're going to be talking more about packages in the next few videos, because there's a lot to it and there's some nuances that come up. So we hope to see you again. Thank you so much for being here. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. We're going to be continuing the topic that we've been going over in the last few videos and talk about more stuff with packages. We're going to discuss how you can pull in a third-party dependency, as in go on to GitHub, Bitbucket, just pull in code that is on another area and use it in your program. And so let's say that I've decided that those functions that I created for add, subtract, multiply, and divide aren't good enough. I don't want to take the time to test them and make sure they're bulletproof, because I want to have more trust in my code, and I don't have enough time to go through that whole process. So I went ahead and found a package on GitHub that has those methods. It's a public repository, calc.go, and it has add, subtract, multiply, and divide. So how do we gain access to this code and use it in our code or in our program? So there's two ways. You can either use the go get command, which will automatically copy this into our Go source and make it available, or we could manually copy it. I'm going to show you how to use the go get, and then I will explain how you would manually copy. I will say it's a lot easier to just use the go get command. And so I already have it right here in the terminal so you can see it. Go get. I'll run this again. So let's look at the name of this repository. GitHub.com / that username I'm not going to try to pronounce. Wait, dhrmkelmendi / go calculator. So let's copy this into here. Say go get space that whole path. But remember, we don't want the main directory. We really just want that subdirectory, that sub package called calc. So I'm going to do a /calc. Go ahead and show you that here. So we just want this subdirectory called calc. So Golang calculator /calc. So I can hit space. It won't print anything out, but it won't give me an error. You can double check to see if it actually pulled your stuff in, is that you will probably see a new directory created in your source called GitHub. And you're going to follow the same path that you gave the go get command. github.com, then that username, and then Golang calculator, and then calc. And we'll see that it actually copied that code from that repository into my Go path. Well, now I have access to it because it's on my machine. I can type in here github.com dHurim-Telmendi. See if I did that right. /Golang _ calculator /calc. And then I can then reference the calc package. Again, the directory is named calc, but the package is also named calc. So I can access it via calc. I'll update my method signatures because they call them add, subtract, multiply, and divide, not the shorthand that I did. So let's see here. We can even get the code hints. Subtract, multiply, divide. We'll see some more errors because as well, the types that their multiply and divide functions are different than what I had. These actually take in float 64, so we're going to do a typecast just so that we can get this example working. There you have it. If I were to do a go run, it works. So I used the go get command to download this third-party dependency that I wanted, and then I referenced it using the path that Go copied that code under. And that path is going to be the same as what you gave it. It'll be github.com /username / whatever, or Bitbucket, or whatever it is that you told Go to get. I'm going to talk a little bit now about how you could do this manually. So instead of using the go get command, you could create the github.com directory, then make the dHurim-Telmendi directory, and then create the Golang calculator and repository and copy everything in, or do a git clone and copy everything in. Or if you didn't want to reference it using that long name, you could just make a calc subdirectory in your source workspace, the source subdirectory in the Go path. Make a calc and just copy the code and use it that way. I will suggest following the naming convention. It keeps things organized, helps remind you where these packages come from. And so pulling in third-party dependencies is not hard. Go makes this very simple with the go get command. But it's really a really good idea at times to use third-party dependencies, because sometimes those third-party dependencies have had a lot of work put into them and they're very well tested. And you can utilize that in your code now. So play around with it. Go look out on the interwebs, on the internet, find some Go packages that you want to play with and import them into a project and try to use them. If you have a good code editor, you will even be able to get type hints from that third-party code. You'll have all the comments and such, and the documentation that comes along with those comments. So thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. And so today we're going to be talking about a new data structure, or a new, I guess you could call it a type, but we have an array. So an array is kind of like a bag that you can hold multiple things in. We've talked about variables, and you can have a variable of specific types, but you can only store one thing in that variable. Well, you can make a variable that is an array of stuff. So let's go ahead and just initialize an array here. So you create an array the same way that you make any other variable, var, and then let's give it an array, my int array, and then you give it the type. And so how you type an array is an opening and a closing bracket with a number inside. I'm going to say 5, and then a type, let's say int. So if I'm going to go ahead and print this out so we can see what this looks like to help give a little better idea of what it is. So my int array. I'm going to do equal sign and then a comma. Let's go ahead and print this out and let you see what it looks like. So you see there, it has brackets with 5 zeros in it. So if you remember the discussion about zero values, the zero value of an integer is a 0. And here we said we want 5 integers in this array. So when it printed out, it showed us 5 integers, all not set, all at the 0 value. Arrays are able to hold one type of data, but multiple instances of that type. And it's a fixed number of things. Once you initiate or initialize an array to hold 5 items, it's going to always hold 5 items. You can't make it hold 6 or 7. Let's go ahead and create another array. Let's say var my string array. Let's make it have 20. And we say, so it's going to be 20 items in the array. You notice how it's brackets, similar to how it prints out. Use brackets here, and when it prints out, it uses brackets. So you do the opening square bracket, the number we want, 20, and then the type that we want to hold. We want to hold 20 strings. So I'm going to go ahead and save this. We'll print this out as well. Oops. Wrong button there. And let's print this out. So you can't see it very well, but there are 20 empty strings right here. So there's 20 spaces inside, because the 0 value of a string is an empty string. It's nothing. So this seems kind of useful, right? Except for it's only holding zeros and empty strings. So let's go ahead and put something a little bit more valuable inside this array here. So let's say my int array. Let's say we want to put the number 20 in the first slot. So when we print this out, we want to see a 20 right here. Something that's interesting about programming in general, when you count in programming, you start with 0. So if you want to count to 3, you say 0, 1, 2. So in this case, we want to put something in the first position. We don't type 1. We're actually going to type a 0. The 0th position. This is the 0 index. Let's put the number 20 in here. So let's go ahead and print this out. You notice, there we go. There's a 20 right here. And we can do this again. Let's say in the 4th index, which is the 5th place. If you're new to programming, this can be very confusing. We want the 5th item, so we want the 4th index. Whatever item you want, it's always -1. Let's put the number 200. Let's do 300. I don't need any more 2s. Here. Now if you look, you have 20, then 0, 0, 0, then 300. Let's do the same thing with our string array here. Let's say my string array. I should probably clarify this a little better. So when you index into an array, you use a similar syntax that you use to create it. We used those square brackets and then a number inside of it. You do the same thing when you want to index into.
Thanks for watching. Feel free to add your questions as comments down below.
An array, but instead of putting it at the beginning, you put it at the end. So the name of your array, then the square brackets, and then whichever index you want to either access or set, you put inside here. Right now we're talking about setting. I'll talk about accessing here in a little bit. Let's say in the 10th place, I want it to equal the word 10. And this will actually put it in the 11th spot. So there's going to be 11 spaces, or 10 spaces in front of it, and then the 11th spot will be 10. So as I was talking about just a little bit, a couple seconds ago, we are setting something at this index. What if we only want to access something at one thing at this index? So let's say with both of these arrays, we actually only want the first index. So I'm going to kind of put that in my print statement. We'll access it similar to how we were setting it. You do the square brackets, and then you type in whatever index you want. So let's say 3. And then on this one, I should probably do 1 because that's what I put in the print statement. So 1 and 1. There we go. So my array, the entire string array, and then this is what's at the first index is a 0, and what's at the first index of the string array is an empty string. Let's put something in this so to make it a little bit more, a little bit easier to see. Second item, but first index. So let's clear this and let's print this out again. There we go, second item, but first index. So I put it in at number 1, and then I can then access it at number 1. Something to note that if we try to access the 5th index, so the 6th element, it's going to give us an error. It's going to say invalid array index 5, out of bounds for a 5-element array. So it's 5 elements, but the 5th element is the 4th index. I'm trying to access the 5th index, which would be the 6th element. This array is fixed to 5 spaces, so it will just yell at me and say, no, I can't do that. Same thing with here. If I were to put in 20, it'll say, no, can't do that. If I were to put 25, it'll say, no, can't do that. If I were to put -1, it would be mad at me because you have to use a non-negative number. In Python, you can use negative numbers for indexes. Go, you cannot. So there you have it. That is a new data structure that you have to be able to play with. So see what it can do. As I always say, see what it can't do. Create an array of certain length, fill it with things, and then practice accessing certain items. In the next couple of videos, we're going to be talking about more ways that you can use arrays, create arrays. So hopefully we'll see you again. Thank you so much for being here. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. So we are going to go ahead and continue the same topic that we were going over in the last video. We're going to be talking more about arrays. Specifically today, we're going to be talking how there are different ways to initialize arrays. So in the previous video, we did as it shows here. We created an array, we initialized it by just saying var, the name of the variable, or the name of the array. Then you gave it the array a length, and then you gave it a type. And then after we initialized it, we would then say at index 5, we want this, or index 0, we want this, index 4, we want this. Well, you can actually do all this in one step. So you don't have to initialize and then fill. You can initialize and fill it up all at the same time. So let's go ahead and do that. So what you're going to want to do is after you were to do your normal initialization, you'd say equals. Then you would repeat the type of the array. It's an array of type int with 5 spaces. And then you'd put curly braces. And let's put 5 integers in. Let's do 1, 2, 3, 4, 5. Now I can get rid of this right here. let's go ahead and print this out. There you have it. You have the array. My int array has 1, 2, 3, 4, 5. So let's go ahead and initialize and create the second array as well. I'm going to change this to 5 because I don't want to type out 20 different strings. And let's use type inference. Here, let's use the shorthand for this one, just so you don't have to type out the array type twice. So it's going to be a string array with 5 items. Let's say 1, 2, 3, 4, and 5. Let's go ahead and save that and print it out. There you go, works just the same. Something to note as well is you don't have to do this all in one line. If you want to, you can break these up into multiple lines. You just have to remember you have to always put a comma there at the end. If you didn't want to put the comma, you could put like the closing curly brace right there, but just don't forget you need the comma there, otherwise it will yell at you. Let's go ahead and run that. There you go. And you can index just the same as the other way that we were doing before. You can do int array, and we can change the, let's put this down here. So let's change the item at the second index to 20. And then print out that my int array again. There you go. Now we went from 1, 2, 3, 4, 5 to 1, 2, 20, 4, 5. And then if we wanted to, we can also index directly into here, just like we were able to before. There, number 5 at the 4th index. So there you have it. That's another way that you can initialize an array. Play around with it, get comfortable with it. Again, as I always say, figure out what you can and can't do with it. Figure out what's going to give you errors and get used to seeing what those errors are, so when you're debugging code, you had experience with them. Thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So we're going to again be talking about arrays, and I'm going to show you one more trick that you can have when you're initializing arrays. And then I'm also going to show you how you can copy arrays and make multiple versions of it. And how when you make a copy, you can change the copy and it won't affect the original. So let's create an array just as we happened before. Let's say my int array, and it's going to be a 5-element int array. And let's put 1, 2, 3, 4, 5. There we have it. And it will yell at me, so let's use it just in a print statement. There you have it. So we've seen this before. This is what we did in the previous video. Something you can do in Go is you can allow the Go compiler to infer the length of the array. So instead of explicitly setting a length, you can put 3 dots in those square brackets. And there you have it. You now have an array of 5 items because you just implicitly knows 5 items because you put 5 items in there. Now it's 6 items long. Now it's 7 items long. You don't have to go in here and change this. So in fact, let's show you a couple new functions that you can do with arrays. So there's actually 2 built-in functions: len for the length and cap for the size, like the total size. So let's say length equals len in fact, let's just say, there we go. So let's print this out. So we have 1, 2, 3, 4, 5, 6, 7. The length is 7 and the capacity is 7. Change this to 8. Length is 8, the capacity is 8. And so something that you'll notice with arrays is that the length and the capacity are always the same. We're going to be talking about something called slices in a few videos down the line, and we'll see that the length and the capacity aren't always the same for those. But for arrays, they are always the same. So there you have it. You can allow the Go compiler to infer the length of the array, and you can just fill it in with as many things as you want. You can only use this for literal arrays. You can't do this with the other syntax when you said var and did this. It'll be mad at you. And in fact, let's see what happens when we do this. Still mad at you. So again, you can only use this syntax when you're doing a literal array. Oops. Yeah, so I just want to make sure I had the correct syntax to show you that it doesn't work. Okay, so let's take a quick moment here and learn how to type. I guess I'm struggling. There we go. Let's take a moment here and let's create a new array. Let's say my int array copy, and we are going to set this equal to my int array. There we go, and we'll go ahead and print this out. And we'll see that the arrays are identical. Well, now let's find out what happens if I were to change my int array, the element at the second index. From a 3, let's turn it into a 30. And we will print both of these out again. Let me label what each are so that we don't forget. Oops. So let's label these so we don't forget which is which. So there you have it. So my int array 1 2 3 4 5 6 or 1 2 3 4 5. My int array copy 1 2 3 4 5. We then change the second index, so the third element. Now my int array, because that's the one we changed, is 1 2 30 4 5, but the copy still stays at 1 2 3 4 5. And you will notice that if we try to change the copy at index 4 250, that only the copy changes and not the original. When you set a variable equal to an array, it doesn't actually give it like a pointer to the array. So if you change the copy, it does not change the original. If you change the original, it does not change the copy. So there you have it. Here's a new way to initialize an array. I showed you two little built-in functions to be able to get the capacity and the length. And also I showed you how to make a copy of an array and showed you that they are completely separate from each other. It is an actual copy, not a pointer. Thank you guys so much for being here, and we'll see you soon. Hello, this is Jace Fugate again with another session of the Introduction to the Go Programming Language course. We're going to be continuing the topic on arrays, and we're going to be talking about one of the reasons why arrays are so useful. It's not only just something that you can hold multiple values in one place, but you can actually loop over all of those items. In my opinion, this is where the power of having an array of something comes in. So I have two examples up here of how you can use looping over an array to do something that you would like. So in this first example, we created an array of 3 items type string. And again, we could have done it this way. We could have put the 3 dots so that we just inferred the size. And again, it wasn't 3 dots because there's 3 items. It's just 3 dots because that's the syntax. I could put in here my name, and it would work just fine, even though I'm not a famous person here. But when this runs, what this is going to do is it's going to create this array. Let me comment this out so when we run it, we don't see the output of.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
The other loop. So it'll create this array, and then what it's going to do is it's going to say, okay, we're going to start a for loop. We're going to initialize a variable to equal 0, and then we're going to say we'll run this loop as long as I is less than the length of names. Again, I showed you in the previous video the len command. It prints out, or it returns, the length of an array. So as long as I is less than the length of the array, run this loop. At the end of each loop, let's increment I. So what this will do is this will run through and print out each item in the array. There we go. It went through and did index 1 first, because I equaled 1, and then it went, or sorry, index 0 first, doing the first element, and then it incremented I to 1, then to 2, then to 3, then to 4, and if you remember, we can't index 4, right? Well, that's okay, because once it got to 4, it said that, oh, well, 4 is not greater than the length of names, because the length of names is 4, so I will bail out and continue through. So once this gets to 3 and tries to increment to 4, it will bail out. And so that's one way that we can loop through and use a loop with an array and print out or access every element in the array. We have another example right down here that does a similar thing, but instead of just printing out each item, we actually will sum all of the items together. So we have an array of 4 items, and those items are all float 64s. And then we initialize another variable called sum, and we initialize it to 0. So this is the same right here. We took a literal integer 0 and it converted it, or casted it into a float 64. We could have done this as well. This would have been the same thing. This would have given us the same thing. And so we do a similar loop as above. We initialize a variable to 0. If you were to initialize this to 2 or to 1, then you would just miss out. You would skip out on the first couple. But we initialize it to a 0. We then say we're going to continue this loop as long as 1 does not get bigger than our length. And then at the end of each loop, we'll increment. And so what this does is it takes sum, and it adds sum plus the item in the array at whatever index I is. We could have done this. We talked about this operator before. Plus equals. That would work the same. But let's go ahead and run this. There you have it. The sum of all the elements in the array of 3.7, 7.2, 4.8, and 9.5 is 25. So there you have it. That is one way that you can iterate over an array with a loop. And then there are 2 examples that we did. One that we just printed them out, and one that we actually used those numbers to create a sum of the whole. Thank you guys so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So we're going to be continuing on arrays, and today we're going to be talking about a different way to be able to iterate over an array with a for loop. So here's a new keyword we're going to talk about today is range. And so what this will do is similar to that I colon equals 0, comma, I is less than the length of the array, and then comma, I plus plus. It's going to allow us to go over each item in the array. So what you do is you have your for loop, and then you declare 2 variables. One is going to equal the index, so that's going to be 0, 1, 2, 3, 4, 5, 6. And then the value is going to be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then colon equals, colon equals range, and then the array that you want to go over, and then the block of code that you want to run. So this will go and first stop at the first element. The index is going to be 0, the value be Monday. It will then run this code, and in our case, it's going to print out the index, format it into the %d, and then format the value into %s. Then it will go to the next element, go to Tuesday. The index will be 1, the value will be 2, and then it continues on that path. It'll be 2 in Wed, Thurs, or 3 in Thurs, Friday, Saturday, Sunday. So let's go ahead and clear this, and let's print this out. There you have it. Day 0 of the week is Monday, 2, 3, 4, 5, 6. Days Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, so let's show another example. So in this example, it will be the same examples that we've seen previously. Is we're going to be summing the values of all of these floats in this array. But you'll notice that we're using the underbar. So what this will do is it will ignore the first value in the array. So if I were to put index in here, you'll notice it'll get mad at me because we're not using index here. So since we're not using it, we can do similar to what we do with when we capture the value from a function. We can use an underbar and say, I want to ignore this. Let's go ahead and run this. You'll notice it'll be similar as it was before. It'll sum everything up and it'll give us 25. So it went through and gave us, first it was 3.5, so added 3.5 to 0. And then it took 7.2, added 7.2 to 3.5, and then 4.8 to that, 9.5 to that. Similarly, you could say, I want the index, but I don't want the value. You will notice though that when I save it, it will tell me, hey, you can just omit that second value. Which we'll go and do that. We'll just erase that. And we'll sum up all the indexes. We do have to cast this to a float, 64, because this is an integer, and then this is a float, 64. So we'll go ahead and cast that, and we'll run this, and then we'll get the number 6 because we just added 0 to 0, and then 1 to 0, and then 2 to 1, and then 3 to 3. But you can use range to loop over an array. You can either grab the index, you can either grab the value, or you can use both over each iteration over. Thank you so much for being here. Definitely play around with this. As I always say, figure out what it can and can't do. And we'll see you again. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. Today is going to be the last video that we're going to be going over arrays. And today we're going to be talking about multi-dimensional arrays. And so in the past, what we've been doing is we've created an array. So let's say my array, and we make it equal to an array of a certain amount of length with, say, integers. And you can use any types with five items. I'm not using it, so it's going to give me an error here. So let's go ahead and print this out so we can remove the error so it's not yelling at us. So there you have it. And as I just said, you can use any type. You can even put in another array. So let's make this into a multi-dimensional array. So we're going to have an array of arrays that are each 2 long. I'm just going to go ahead and print this out so you can see what it looks like just at that 0 value. Oh, I apologize, I was on the wrong file. See, we all make mistakes, right? Okay, let's go ahead and run this again. There we go. So we have our first array and then our second array. So I'm going to increment this first number. And you'll notice we'll have the first array, the second array, and the third array. And you notice that the second number is 2. So each sub-array has 2 items. So I'm going to go ahead and increment this to 4. There, now we have 4 of them, and now I'm going to increment the second number to 3. And you notice that instead of having a set of 2 zeros, we're going to have a set of 3 zeros. So let's go ahead and initialize this. Let's not just leave it at a 0 value. So let's make, on the first array, everything will be, let's leave it at 0, so we're going to have 3 zeros. In the second array, let's do 3 1s. Third, we'll do 2s. The fourth, we'll do 3s. And as I mentioned briefly in one of the other videos, you do need that comma at the end. You do need this comma here. Let's go ahead and run this. You have it, so you have 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3. Let's change this up. Let's just make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's think about how we can access these elements individually. So let's say we want to get this 5 out. So this is going to be the 1th index array, and then you put another set of square brackets after that first set, because this one matches with this, and that is which array we're in. And then we want the 1th item in the 1th array. So go and run that. There we have it. There's number 5. So let's say we want to get the 12. So that's going to be the 3rd indexed array, and then the 2nd indexed item in this array. Remember, you always take which position it is and subtract it with 1. There you have it. Now we got the 12 that we're looking for. The same goes with assigning. Let's say I want to change that 12 that I'm printing out. I want to change it to a 21. Let's flip it. There we go. Now I have 12, and then I change it. I assign it. So I'm taking the 3rd array and the 2nd item, or the 3rd item of that 4th array, I should say, and I'm changing it to 21. We can also change out the entire array. So if we don't want to just change out one item, let's say we want to change the entire 3rd array to 0, 0, 0. We're going to notice how it gets mad at me. I have to give this array a type. So I'm going to say it's going to be 3 long filled with integers. So let's just print out that 3rd array this time. So it went from 10, 11, 12, then it went to 0, 0, 0. And we can put as many of these in as we want. We could put another set of arrays. So this would then make all of this another set of arrays, even one more deep. There you go. So let's print the entire array, or I guess it's a 3-dimensional, 4-dimensional array here now. Yeah, 3-dimensional array. Print this whole thing out now. There you have it. So we have the big outer array that is a set of, this is one of those. There's the second one, the third one, and then the fourth one. And then inside each of those, there's 3 items, which are also arrays. And then inside of each of those, there's 2 integers. And that pattern is repeated throughout. So multi-dimensional arrays are very useful. They can be used to be able to hold information in
Thanks for watching. Please like and share this video.
multiple dimensions, I guess. I don't know if I can explain it much better than that. You can use it to display maybe a checkerboard if you wanted to, if you did the two-dimensional array. So I'll undo here. So if you did like a two-dimensional array, you kind of think of that like a checkerboard. You have like a two-dimensional thing, or three-dimensional, fourth dimension. So play around with it. As I always say, see what you can figure out what you can and can't do with it. Get comfortable with these, because you can use multi-dimensional arrays for a lot of very useful things. Thank you so much for being here, guys, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So today we're going to be talking about arrays, sibling, or very, very close cousin, slices. So slices are the same concept as arrays, but instead of them being fixed length, they are variable length. And so you initialize a slice the same way that you would an array, but instead of putting a number between the square brackets, you just don't put anything. So let's go ahead and print this out. And let's run this here. There you go. It prints out just square brackets because we initialized a slice and it first starts out with 0 items. If we wanted to, we could initialize this with some stuff in it. There you go. So very similar to initializing an array, but again, we just don't put a number. There you have it, 1, 2, 3, 4. And we can do the same thing. We can use type inference, so we don't have to put that first type because we're giving it the type here. Same thing, or if we wanted, we could also use the shorthand variable declaration syntax. Arrays are the same when it comes to indexing. So if we wanted to change the first item, we could. Or if we wanted to just access the first item, you could. Same way, you use the square brackets and then you put in the index that you want to access, whether setting or getting. So arrays and slices are, in a usability standpoint, almost identical. Again, slices are nice because you don't have to give it an initial size and you're not bound to that size. So let's go ahead and use the len and cap here. Let's print out the length. 4. We're going to print out cap. 4. It's interesting. They're the same, just like arrays. In the next few videos, we're going to be using the same functions on slices, and we're going to show that they actually can become different. So a heads up with me on how I usually code in Go is I almost 100% of the time use slices. I think slices are just easier to use because, again, you don't have to give it the size beforehand. That being said, you can give arrays a heads or like a little bit ahead of slices because of performance. A slice really just uses an array under the hood. If you add more elements to a slice, it will just create a new array under the hood, copy items from one slice, put them into the other, and then there you have it. I haven't found a case where that has mattered too much to things that I'm doing, but it depends on the performance needs of your program. But there you have it. That's just the first glimpse to slices. In the next few videos, we're going to be going over some more of the intricacies of slices and how to use them. Thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. We're going to be continuing our talk on slices. So I'm going to show you another way you can actually create a slice. So you can actually create a slice from another slice, just like you could create an array from another array. It differs a little bit. We'll talk about those nuances a little bit in this video and in the following video. So let's go ahead and create a slice. So let's say first slice. And in fact, let's do even more short. Let's just do S1. Let's do integers as I like. 1, 2, 3, 4, 5. Be mad at me because I'm not printing it out. I'll say this is S1 equals S1. Oops, forgot a comma. There you go. Let's run this. So it prints out 1, 2, 3, 4, 5. So we can create another slice, say S2, by putting it equal to S1. Oh, I'm not printing it. Let's fix that. S2. There you have it. It's just identical. As well, if we wanted to, we can make an array 1 and set it equal to 5 items, integer, 1, 2, 3, 4, 5. And in fact, let's make this a little different. So let's do 6, 7, 8, 9, and 10. And now let's print this out so it stopped yelling at me and we can see it visually. There you go. Here's A1. Now let's make a slice out of this array. So it's similar to how we've been doing before. Let's make a slice 3. Let's see what happens if I just do A1. Well, that would just turn S3 into an array, right? Because that's what we showed before. That S3. That'll just create another array, but we want to create a slice. So what you can do is you can say, I want from the 0th index up to and not including the 5th index. There is no 5th index, and so that will do 0 through 4. There you have it, and there's this first one is an array. It's fixed length. The second one is a slice. It is not fixed length. And if we wanted to, we could say, I want from the 1st index to the 5th, or up to and not including the 5th. And there you have it. Now we just chopped off that first one. If we do 2, it'll chop off another one. And we can go to the other side as well. We could turn this to a 0, and let's say we want to go to the 4. Again, I just want to reiterate. This first number here is the first item that you want. The second item is exclusive. It says up to but not including this item. Let's go ahead and run that. There you have it. It chopped off the last item that time. We could as well just completely omit that first element or that first number, and that just says from the beginning I want everything. You can do the same for the end. You could just omit that second number. You have it. Same thing. It goes all the way to the end. If you really wanted to as well, you could omit both of them and just say, hey, I want just everything in this array. I want to turn it into a slice. So there you have it. That is how you can turn one slice and copy it into another slice, and how you can turn an array or take a slice of an array and turn it into a slice. There are some gotchas with this, and we're going to talk about this in the next video, but play around with it and see what happens. See what happens if you try to change certain indexes on one and see what happens with the copy. And this is what we're going to go over in the next video. Thank you so much for being here, and we will see you soon. Hello, this is Jace Fugate with another session of the Introduction to the Go Programming Language course. In the last video, I kind of alluded to some gotchas that come with making copies of slices and just using slices in general. So let's go ahead and show you. So let's run this. This is the same example that we had in the last video. As we see here, we have first slice, we create another slice out of that first slice, then we make an array and then create another slice out of that array. Now, what would happen, let's copy all this down, we're gonna do some modifications. What would happen if I took the first element of the first slice and from a 1 turned it into a 10? And I'm going to comment this out for now. Well, if you notice here, both of the slices changed. When you made just an array out of another array, when you changed one array, it did not affect the other array. With slices, doesn't work that way. If you make a slice of another slice, if you change the first one, it will change the second one. Same goes the other way around. If I were to change, excuse me, wrong button. If I were to change the second item, or the fifth item, or the fourth index, it would change both of them as well. Well, let's see if this comes true with arrays as well. Oops. So let's uncomment this out. Let's do array 1, 0 equals 100. And let's change S3, 4 to 500. See what happens. Oh, you have the same result. So when you create a slice, you can almost think of it as a window. When you're making a slice from another slice or a slice from an array, you can kind of think of that copy as a window to the original. When you make a change in one, most likely it's going to be making a change in the other. And you have to remember this because it can cause some headaches sometimes when you want to make a copy of a slice and you then change that slice and you get unexpected results. Thank you guys so much for being here. We'll talk more about slices in the next video. We hope to see you soon. Hello, this is Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're going to be talking about updating the length of a slice. And so first off here, we have a slice with 10 elements in it. Let's go ahead and comment out these other lines of code, and let's just run this first print statement. So S is the original slice, the length is 10, the capacity is 10. Well, let's change the length. We're going to take a slice of that original slice and then overwrite the original slice. We're going to take the first element up to and not including the fifth element. So now let's print this out. Oops, forgot to save. I'll clear this, make it a little more visible. There we go. So after slicing from index 1 to 5, the slice now contains 20, 30, 40, and 50. The length is 4, and the capacity is 9. And you notice how the capacity is excluding that first element right here. Let's do another example. Let's change this slice from the beginning of this current slice up to and not including the 8th element. There we go. So we did not get that 10 back, but we just got the 20. And then the capacity is 9. 1, 2, 3, 4, 5, 6, 7, 8. It's interesting. Capacity is still 9 even though we changed the length. So the underlying array is still this right here. On that first slice, we changed the head to here and just said, hey, stop after this much. Well, we sliced it and extended the length. Okay, it's interesting. Let's go ahead and do another example.
Thanks for watching. Feel free to add your questions as comments down below.
This time we're going to go from the second to the end. So we dropped the first two elements. So now the head, or the beginning of this slice, got moved forward 2 elements from here. But we went to the last element that we had access to. If we wanted to, well, what would have happened if we would have changed this to a 9? Let's find out. Well, we got that 100 back. So this can be confusing. This can possibly not make sense to you to start off with. So you really need to play with this. Try to figure out what it is that's going on. We first started off with this slice. You could think of this as a window to this array. We then changed the size of that window to cut off the first index, or cut off the 0th index, and only allow us to see up to and not including the 5th one. We then changed that window and kind of shifted it back a little bit more to view to the 8th. Well, let's go ahead and continue this playing around. Let's change this to 10. What's going to happen? It's going to get mad at us. So you can't go past the size of the original array when you're doing this slicing right here, or doing this this windowing, I guess you could call it. You have to stick to the capacity, or you can't go past that original size. Like I said again, you really just need to play with this so you can figure out what you can and can't do, figure out what happens if you were to now modify it and then change the slice. With practice comes knowledge. We're going to talk more about modifying these slices in the next few videos. Thank you so much for being here, and we hope to see you again. Hello again, Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're just going to quickly show you how to initialize a slice using the make command. So let's say my slice colon equals, you can use the word make parentheses, and you notice it kind of gave me a little definition here of what you do. You're going to put the type and then the size. So I'm going to make a slice of integers that is going to be of size 6. Now this does not bind the slice to only ever be 6 long like it does an array. It just says that we're initially going to create the slice 6 long. Under the hood, what it does is it creates an array of 6 elements and then gives us a slice window to that array. So let's go ahead and print this out. And this will be similar to when you initialized an array of 6 elements. It'll print out a bunch of 0 valued. 6 integers, 0 valued. Thank you so much for being here, and we will see you again. Hello, this is Jace Fugate here with another session of the Introduction to the Go Programming Language course. Previously, in another video, we talked about using the make command to create a slice. Now let's use that same concept and show you how you can copy from one slice to another. So let's create a slice. In fact, let's just make this S1, and we'll just make my slice. We'll make this slice 2 or S2. Integers and 1, 2, 3, 4, 5, 6. So we need to make sure that when we're doing copying that our slices are of the same type and the same size. So if I were to print this out right now, you would have 1, 2, 3, 4, 5, 6, and then S2 would just be a bunch of zeros. Well, now let's copy everything from slice 1 to slice 2. You may think, oh, okay, we're going to do this. We're not going to do it that way, actually. We're going to show you a new built-in function. It's called copy. You say here, copies elements from a source slice to a destination slice. And so we'll say the source slice is 1, the destination slice is 2. Oh, I apologize, got that backwards. The destination slice is 2, the source slice is 1. So the destination comes first, the slice comes second. There we go. So the first time we print it out, and then here we have it, it gets printed, it gets copied over. Well, let's see what happens when we edit S1, 100, and let's edit S4 equal 50 on the second slice. Well, I guess I should probably print out, shouldn't I? There you go. Well, there you have it. They didn't change that time. So when you use the copy method, you actually will get a different slice. So if you edit one, it will not affect the other. This is contrary, this is different than if you were to do this. If you did that, you would edit one, editing one would change the other. But if you use the copy command, it makes an actual copy and it doesn't have one reference the other. Thank you so much for being here, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're going to be talking about appending to a slice. So here we have a slice that is initialized to 2 elements. And so if I go ahead and run this, it'll print out that I have a length of 2 and a capacity of 2. So let's go ahead and add one more element to the end here. So let's say S1, that's how you append, equals the built-in function append, pass in S1 again, and then what it is that you're trying to append. Let's append the integer 3. But also, let's print the length and the capacity, and we'll see how that actually changes. So we added one element, making the length 3, but now the capacity became 4. So what's happening here? So when the length is 2 and the capacity is 2, the capacity is the size of the underlying array. The length is how many of those elements we're seeing. When we appended, we added a third element, but the capacity was only 2. The array that we had, like the underlying array, was only 2 long. So we had to actually created a new array, copied the first element, the second element, appended the third element to it, and then gave that back to us, saying that, okay, now here's your underlying array for your slice. But it didn't just make the array 3 long. It gave us a little bit of headroom because it doesn't want to have to constantly be copying things over every single time you append. So it actually created that underlying array to be 4 long. It doubled the length. So let's do this again. Let's do 4. So we'll see it as length 4, capacity 4. Let's add a 5th element. Now the length is 5, but the capacity is 8. We hit our limit when we try to add a 5th element, so Go created a new array, double the length or the capacity of the last one, and then added that 5th element. And if we were to continue this pattern, 1, 2, 3, 4, 5, let's add a bunch more, and we'll notice that it continues to double once we hit that cap limit. So this is good to understand how Go does the underlying data structure of slices, so that when we append, if it has to, it will create a new underlying array. One thing I want to show you before we close off this session or this video, what would happen if I were to not, let's say I just did this append right here. And didn't have it equal. What would actually happen is this would append that item, and if it needed to create a new array, we would have no way of capturing that back into the original value. The Go linter or the Go compiler will actually stop you from doing that. But if it did let you, you'd be in trouble, because you would create a new array, you'd pass it back with the append, and then you wouldn't catch it, you wouldn't capture it, and you would not see that your item was appended, because your variable would still hold the pointer to the old array. This is a really interesting topic to me. I like data structures, I like algorithms, but play with this, see what you can and can't do, get to know it very well, and we will see you again. Thank you so much for being here. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So we're going to be continuing on slices. So today, what I'm going to be talking about here in this video are two more things that we want to make sure that you know about when it comes to appending to slices. First thing I'm going to talk about is that appending to slices is a very safe operation. I'll explain that here in a little bit. And as well, I want to show how you can concatenate two slices or combine two slices, or you could also say you can append one slice to another. So let's go ahead and talk about the safety aspect here. So I'm going to go ahead and print this out. So go run, you notice it prints out an empty slice. Well, let's do what we've done, and let's append on the number 1, and we'll go ahead and print that out again. And there you have it. Now it was an empty slice, and now it's a slice with the number 1 in it. So we haven't talked too much about what the nil value means. The short form of it is nil means nothing is there. Not every type can be set to nil, but slices can be set to nil, or can be nil. So I'm going to go ahead and initialize this as nil, which means this variable is supposed to be a slice, but it doesn't have anything underneath of it. As in, we talked about that slices use arrays under the hood. Well, this is initializing the slice with no array under the hood. Some might think that if we append to a nil slice, it's going to error out. But Go is smart, and Go will notice, oh, you have a nil slice. Well, I'm just going to treat it in most cases that it's actually just an empty slice. So that works just fine. We appended 1 to a nil slice, and it just created the array under the hood and just went along with it as if it was never nil in the first place. That's pretty cool. That's a very nice safety feature that Go gives us. Okay, now let's go ahead and move on to, now let's say we have our nil slice, and we have another slice, and it's going to have integers, of course, and let's put my favorite numbers in here, 1, 2, 3, 4, 5. It's yelling at me because I'm not using it. So let's put S2. I'm going to hit save, and you're going to notice it's going to yell at me and say, hey, you can't use a slice of integers as an integer. So something that's interesting with the append function, it's not required to only pass 2 things in. If we wanted to, we could pass in this. We could actually append more than one thing at one time. It's a variadic function. That's a topic to go over fully at another time. But basically that just means that it can take...
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
a bunch of parameters of the same type right here. Oh. So we could do that. So if I were to run this, we'd have a slice that now has 1, 2, 3 because we appended these items onto it. I'm going to go ahead and change this from a nil slice. Let's turn this into something real here. In fact, let's just say 0, so we can keep things in a sequential. This is my OCD coming out here. Keeping things good. So there we go. So we have 0, 1, 2, 3. Well, what if this array had 100 items, or what if we didn't know how many? I'm sorry, this slice. I said array. This slice has 100 items, or we just don't know how many items are in it. We're not going to want to type that out, or we can't because we don't know how much to type out. So what you can do is you can do S2, and then you can do 3 dots at the end. That will, in the lack of better terms, that will explode this array into its individual items. So this will make the compiler look at this array as if it was each individual index, each individual item. So it's as if we did S2 sub 0, sub 1, sub 2, sub 3, sub 4. Let's go ahead and run this and we'll see. There we go. Now we have all of the items appended on. And so this is how we want to concatenate 2 arrays together, or append one array to another. And there are some other ways that you can use this syntax. Today we're just going to be talking about it here in the scope of appending, but you can always explode an array into a variadic function. We will go over this more in another course. It's a little bit more advanced than just for this beginner course, but it's something that I would like for you to be aware of. It's something that you can go ahead and play around with or learn some more about it on your own. So there you have it. As I said, play with this. And as I always like to say, figure out what it can and what it can't do. And thank you so much, and we will see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. So we're going to be continuing on slices. Today we're going to be talking about multi-dimensional slices. This concept hopefully is familiar to you because we've done multi-dimensional arrays, and it works exactly the same. So let's create a multi-dimensional slice here. My multi-dimensional slice. And let's have this 2 deep, and it takes strings. And I will print this out. Okay, let's go ahead and run this. Okay, there you have it. It's interesting though, is it's just one single set of square brackets. So as we've been talking about, is slices are variadic, as in they can their sizes can change, can grow and shrink. And so right now this is a slice of string slices, but there are no inner string slices that exist, so it just shows the outside parentheses. Let's go ahead and initiate this, or initialize this, so that we actually have something in the middle here. There you go. So we have a slice of string slices, and inside I created a string slice, an empty string slice. So I'll go and run this, and there we have it. Now we have 2 sets of brackets. And I can put in here first. I'm gonna do 1, or actually 0, 0. two-dimensional, kind of think of that as 0, 0. And then I'm going to do another one here. This will be 0, 1. Oops, I did a rune. Runes don't like multiple characters. There we go. There we go. 0, 1, or 0, 0, 0, 1. I'm going to put some these around just so we can separate the numbers up a little bit. I'm not sure if that made that better or worse, actually. Okay, so let's go ahead and add another slice into this. This is going to be 1, 0, 1, 1. There we go. And it's going to start looking very similar to the multi-dimensional array that we had. The difference is, again, is that these can be variable length. These inner slices don't have to be the same. I can make this one different size. I can go ahead and add a 1, 2 onto this. So now that's completely different. I could put as many of these on if I wanted to. I could add a new slice to it. So let's say my MD slice. Let's append to my MD slice a new string slice, and let's make it empty. And there you have it. And if we wanted to, we could say my MD slice sub 0 append to my MD slice sub 0. Another, and this is going to be a string because the inner set takes just a string. So let's go ahead and add, this will be 1, this will be 0, is that what it is? Yeah, 0, 2. Keep doing backslashes here. There we go. There we have it. We just appended on into the inner slice. And so this is something that can kind of get confusing. It's almost like Inception going on here. You have slices going inside slices, and now you're appending to a slice that's inside of a slice, and we can make this a third deep, and you could be appending a slice that's inside of a slice that's inside of a slice. It can get a little bit confusing, so practice. Play with it. Figure out what you can and can't, as I always say, what you can and can't do with it. And it'll make more sense the more you use it. And you'll see that multi-dimensional slices are very useful. They're great to have. Because sometimes you don't want to store everything in a straight line. You want to be able to have it, if maybe you're doing a game with checkerboards and you want to be able to have that two-dimensional kind of idea in the actual data structure. Or maybe it just makes sense to do the multi-dimensional slice. Sometimes that just is the best way of doing something. Thank you guys so much for being here, and hope to see you again. Hello, Jace Fugate here with another session of the Introduction to the Go Programming Language course. Today we're going to be going over our last video talking about slices. And this concept again should be similar to arrays, so hopefully this catches on very quickly because you do the same thing with arrays that you do with slices. We're going to be talking about how we want to iterate over the elements of a slice, or we use a for loop to iterate over the elements of a slice. And so I'm going to show you three things. I'm going to show you how to do it using your classic for loop with the variable that you initialize. You have your condition and then the thing that gets run after. I'm then going to show you how you can use it with range, and then show you how the underbar, or that blank identifier, can be used with it as well. I will go ahead and comment this out so when I print things, we only see the one. And so here we have a slice of strings called countries. And then right below it we have the for loop. We initialize our variable. We then say as long as I is less than the length of countries, so as long as I is less than 4, we'll continue this loop, and after each loop iteration we want to increment I. Then inside the loop we're just printing out whatever element is at the index that I equals. Let's go ahead and run this. And there we have it. It prints out India, America, Russia, England. And this should be, and hopefully it is, almost sounding like it's a repeated video, because you're going to be looping over arrays exactly the same as you do slices. And that being said, we can switch this, and let's do index, comma, value, colon equals, the keyword range, and then the slice that we want to iterate over. And then here I'm going to change this to printf, and let's say value is, and oops, not value, but key is, and value is, and then we'll place in the index into this first format verb, and then we'll place in the value into the second format verb. We'll go ahead and run that. I'll go ahead and explain this. What the range does is it will, when used inside of a loop, it will iterate over each item in a slice or in an array, and each iteration it will return the index and the value of the element that we're looking at right now. And we can use that the underbar if we wanted to. So if we wanted to omit index, because maybe we just don't need the index, let's just get rid of that, and maybe we just care about the value. So you can remove that and it will run just fine. As well, you can remove the value if you don't need the value, but Go will say that it's a little unnecessary what you're doing, and that you should just omit that second value completely. If there's only one variable on the right side of the range, then it will just place the index in there. Okay, and below we have another example. This is the same example that we were showing when we were going over arrays. And this is using a sum variable to add up everything inside this array. So I will clear this. Let's go ahead and run this. Let me look at this for a second, and oh, look at that. Didn't comment that out. There we go. Apologize for that. So let's run this again. I'm telling you, everyone makes mistakes. So we'll go and run that, and we get the total sum of 25.5. And we can use, if we want, this I, and then the condition, and then the after command. Or we can switch this over and say I don't need to use the index. I just need the number. Range numbers. And then I can just say the number, I want to sum the number plus equals. Remember this right here, this is the same as doing this. Just a shorthand, saves you some typing. And for some people it's a little cleaner as well. So we can do that just fine. We can go and run it, and there we have it. We have the same value. So I'm going to say this for probably the 50th time, but arrays and slices, when you're iterating over them, work exactly the same. But still play around with doing it with both arrays and slices, just to remind yourself and drill it into you that how to do this and what you can and can't do with it, as always, as I like to say. Thank you guys so much for being here, and hopefully we'll see you again. Congratulations, guys. You've gone through the introduction course to Go. Thank you so much for being here, and I hope that you learned a lot. We're going to go ahead and do a recap of this whole course, just to make sure that you learned everything that you feel like you should have learned. If there's anything here that sounds unfamiliar, definitely look back and see what you could have missed. So yeah, let's go and switch over to the PowerPoint here, and let's go over some of the topics. So some of the topics you should have learned here in this class is how to get Go set up on your system. And learned a little bit about the Go environment. So the Go path, the workspace, those kind of things. Hopefully you've learned how to.
Thanks for watching. Please like and share this video.
Create just a simple hello world program. You should have been able to write that program, run it, and then actually compile it into a standalone binary. We went over variables, talked about zero values, talked about type inference. Let's go ahead and jump over here to the next slide. We went over just some of the basic types that those variables can be. So we went over the numeric types like integers, floats 32, float 64. We went over complex numbers. We talked about booleans, strings, runes, and we also went over some of the operators that we can use with numbers to be able to manipulate them. And then we even went over type conversion, so how you can take a variable of one type, convert it into another type. Then we jumped into constants. You should understand that constants are similar to variables, but how they are immutable. And then there's just a little bit of nuances when it comes to actually instantiating them, how you can't use like the short syntax, the colon equals, when you're instantiating constants. We jumped over to the a little bit more complex stuff here with if statements, else ifs, the control flow statements, I should have said, ifs, else ifs, the else's, switches. Talked about loopings, all the different ways you can use for loops with like 3 statements or with range, or you could do an infinite loop if you wanted, if that was something that suited the needs of the program. We jumped over into functions, talked about how you can separate code, make it a little bit more reusable. You can return one or many arguments or one or many return values, and then talked about even how you can use the error type to be able to indicate that something went wrong, because there are no, you don't throw exceptions in Go. You return an error, and then the caller then checks the error to see if it exists or not. We jumped into packages, separated the code even more, and even showed you how you can pull in a third-party dependency. And we also went over arrays and slices, talked about how they are similar. They hold data in an organized way in like a single variable, but how slices are like an abstraction around an array so that you can have a variable lengthed array. So congratulations guys, seriously, you have finished the class, and hopefully you've learned all those topics, and hopefully you really enjoyed it. We really hope to see you again. Some of the other things that I want to talk about here are the private tutoring sessions. And so if you feel like you've been struggling in any way, feel like you want to be able to just learn faster, check out the weekly and monthly plans that we have for private tutoring sessions. As well, you can go over software design and engineering in general, or you can go over more specific topics like Go programming language. Some of the other courses and next classes you can look into, we have the Hyperledger Fabric for developers and the Hyperledger Sawtooth for system administration. Check those out, see if those are some that you feel would be useful to put into your tool belt. There you have it. This is another tutorial with codingbootcamps.com. codingbootcamps.com. Follow us on Twitter, on Facebook, Instagram, all the great places that you expect to see good content and good stuff. See you on the next class. Just a little plug for myself here is this probably isn't going to be the only course I'm going to be going over. So if you liked how I taught and thought that the class went well, definitely check me out in some of the other videos, and definitely check out some of the other instructors. There's some really great instructors and some really good content here on the site. Thank you guys so much for being here, and we'll see you again.